Imagine a future where the stars are dead. No light, no warmth, just a cold, endless void stretching forever. Sounds like something out of science fiction, right? But this isn't some made-up dystopian nightmare. It's the inevitable fate of the universe. And at the heart of this dark future lies something that has never been seen before. Something that, as far as we know, doesn't even exist yet. Black dwarfs. If you've never heard of a black dwarf, you're not alone. Most people haven't. And that's because right now, the universe is too young for them to exist. But they will exist, given enough time. They're the final stage of a star's life, the ultimate fate of small and medium-sized stars like our own Sunday. But here's where it gets crazy. Black dwarfs will take longer to form than the current age of the universe. We're talking numbers so big they start to lose meaning, trillions upon trillions of years. By the time black dwarfs finally appear, the universe will be unrecognizable. No galaxies. No nebulae. No life. Just scattered remnants of dead stars, barely distinguishable from the frozen blackness around them. But what exactly is a black dwarf? How do we know they'll exist if we've never seen one? And what will the universe even look like when they finally emerge? To answer those questions, we have to go back, way back, to the beginning of everything. Because understanding black dwarfs isn't just about the future. It's about the entire history of the cosmos, from the birth of the first stars to the slow, inevitable death of everything we know. Right now, every star you see in the sky is either in its prime or approaching the end of its life. But not all stars die the same way. The biggest ones, massive, burning giants, explode in spectacular supernovas, leaving behind black holes or neutron stars. But stars like our Sun? They die quietly. When their fuel runs out, they puff up into red giants, shed their outer layers, and leave behind a small, dense core called a white dwarf. White dwarfs are strange objects. They're about the size of Earth but contain nearly the entire mass of the original star. That means they're insanely dense. A single teaspoon of white dwarf material would weigh tons. They also don't generate new heat. Instead, they glow faintly from the leftover energy of their past life. Over billions, even trillions of years, they cool down, fading from white to red to black. And when that final stage happens, when all the heat is gone, when there's no more light, that's when a white dwarf becomes a black dwarf. But here's the catch. The universe simply isn't old enough for that to have happened yet. White dwarfs take an unimaginable amount of time to cool down completely. The oldest ones we've observed are still glowing faintly. Even though the universe is already over 13 billion years old, that's nothing compared to the time it will take for a white dwarf to become a black dwarf. It's estimated that this process takes at least a quadrillion years. That's a 1 followed by 15 zeros. And that's just a minimum estimate. Some calculations suggest it could take up to a googol years, a 1 followed by 100 zeros. At that point, even the concept of time itself starts to lose meaning. So if black dwarfs don't exist yet, how do we even know they will? The answer lies in physics. Everything we understand about heat, energy, and stellar evolution tells us that white dwarfs have to cool down eventually. There's no other possible outcome. No new energy source means no way to stay warm. The laws of thermodynamics demand that, given enough time, every white dwarf in the universe must become a black dwarf. It's not a question of if, only when. But here's where things get really weird. The idea of black dwarfs is already strange enough, stars so cold and dead that they're almost indistinguishable from space itself. But there's something even stranger about them. Theoretically, given even more time than the universe has existed by an unthinkable margin, black dwarfs might not just sit there, cold and dead. They might collapse. That's because of something called quantum tunneling. It's an effect where particles can, over an extremely long period, randomly change position due to quantum mechanics. Normally, this is only noticeable on tiny scales, like in atoms. But over insane amounts of time, far longer than the age of the universe, this process might cause black dwarfs to shrink and eventually collapse into black holes. If that's true, then in the far, far future, the entire universe could be nothing but scattered black holes, remnants of stars that died trillions upon trillions of years earlier. And then, even those will disappear. Black holes aren't truly immortal. Thanks to something called Hawking radiation, they slowly lose energy over time. And in an even more distant future, so far away it's almost beyond human comprehension, even the black holes will be gone. Nothing left. Just an empty, silent void. A universe that has reached absolute zero, where even atoms themselves have decayed. The true end of everything. But that's getting ahead of ourselves. Right now, we're still in the bright, active era of the cosmos, where stars burn and galaxies shine. Black dwarfs are a future we'll never see. No human, no civilization, no living thing will ever witness their formation. They belong to a timeline so staggeringly vast that it makes our entire existence feel like an instant. Yet, in a strange way, the idea of black dwarfs is almost comforting. They remind us that the universe isn't just a place of chaos and violence. It's also a place where things follow a predictable path, even if that path takes longer than we can comprehend. Stars are born, they burn, they fade, and eventually they die. And in their final, quiet moments, they leave behind the coldest, darkest objects imaginable. The last remnants of a universe that once burned bright. But if that's the end, then what comes after? Could there be a cycle beyond even this? Could the universe somehow restart, birthing new stars from the remains of the old? Or is true nothingness the only possible outcome? These are questions no one can answer yet. But one thing is certain, the story of the universe isn't over. Not yet. And as long as there are mysteries left to uncover, as long as there are questions left unanswered, we'll keep searching. Because if there's one thing we know about the universe, it's this: the more we learn, the more we realize how much we don't know. The idea of black dwarfs is already mind-blowing, but the more you think about it, the stranger it gets. Imagine a universe where black dwarfs are the only things left, stars that have cooled for so long they no longer shine, drifting in the darkness. They wouldn't be visible to the naked eye, not even with the most powerful telescopes. No light, no heat, just frozen spheres of degenerate matter, scattered across an empty cosmos. The only way we'd even know they were there is by detecting their gravitational influence, the faint tug they exert on whatever else remains. But by then, there might not be anything left to feel that pull. To really understand what a black dwarf would be like, let's talk about what happens inside them. When a star becomes a white dwarf, it's already one of the densest objects in the universe, just short of neutron stars and black holes. It's held up by something called electron degeneracy pressure. Essentially, the rules of quantum mechanics prevent electrons from being squeezed too closely together. This keeps the white dwarf from collapsing further. But as it cools, something interesting happens. The atoms inside it stop moving as much, the energy levels drop, and over time, the structure changes. Theoretically, a black dwarf could become something incredibly bizarre, a nearly perfect crystal. This is because as the white dwarf cools, its interior atoms settle into an organized structure, like a giant diamond floating in space. In fact, some scientists believe that the first black dwarfs might be enormous, planet-sized diamonds. But unlike a real diamond, these wouldn't sparkle. They wouldn't reflect or refract light because there is no light. They would just be there, cold, silent, and eternal. But how cold is cold in this context? We're not talking about the kind of cold that freezes water or even the coldest places on Earth. A black dwarf would be as cold as space itself, which is just a fraction above absolute zero. At absolute zero, all motion stops, atoms no longer vibrate, molecules no longer move. It's the lowest possible temperature in the universe. A black dwarf wouldn't quite reach absolute zero, but it would be close. So close that, for all practical purposes, it would be a lifeless, frozen relic of a past universe. But here's another mystery: could black dwarfs interact with anything? Could they collide? Could they form planets around them? It's an interesting question because, theoretically, even in a universe filled with only black dwarfs, gravity would still exist. They could still pull on each other, drift together, and even, over unimaginably long timescales, merge. What happens when two black dwarfs merge? No one knows. Would they create enough energy to briefly shine again? Or would they collapse into a black hole? And here's another thought. What if, even in this cold, dead universe, there were still chemical reactions happening? Could the bizarre conditions inside a black dwarf create elements we've never seen before? Right now, our entire understanding of chemistry is based on a universe with stars, heat, and energy. But in a universe with none of those things, entirely new processes might emerge. It's a weird thing to consider, life after the death of stars. Could there be some strange form of matter, some slow, barely detectable reaction taking place inside these frozen husks? Could they, in some way, still be changing even when the universe itself has stopped? And if that's the case, is the end of the universe really the end? Or is it just the start of something else? If black dwarfs will one day fill the universe, then we have to ask ourselves, what will the universe even look like by that time? Right now, space is filled with light. Stars burn at all different stages of their life cycle, from young, massive blue giants to aging red dwarfs barely clinging to their fuel supply. Galaxies swirl together, supernovae explode, and black holes consume matter in a violent ballet of creation and destruction. Even the darkest regions of intergalactic space still contain faint traces of energy from the cosmic microwave background, the afterglow of the Big Bang. But all of that is temporary. Over time, stars will burn out, galaxies will drift apart, and the light we take for granted will fade. The first step in this process will be the slow death of star formation. Right now, stars are born from massive clouds of gas and dust, pulled together by gravity until nuclear fusion ignites in their cores. But that process isn't infinite. Every time a new star forms, it uses up some of the available hydrogen and helium, the basic building blocks of stellar life. Over trillions of years, the supply of free-floating gas will dwindle. Star formation will slow down, then stop completely. The last stars to ever form will be small, long-lived red dwarfs, which can burn for trillions of years before eventually fading away. But once they're gone, that's it. No more new stars. No more fusion. No more light. At this point, the universe will enter what physicists call the degenerate era. This is the beginning of true cosmic darkness, a time when the only remaining objects will be stellar remnants, white dwarfs, neutron stars, and black holes. But even these won't last forever. White dwarfs, as we've discussed, will slowly fade into black dwarfs, taking trillions upon trillions of years to radiate away their last bits of heat. Neutron stars, those ultra-dense cores left behind by supernovae, will likely survive for even longer, but they too will become nothing more than cold, inactive husks. The only things that will remain truly active in this era are black holes. Black holes are different from other stellar remnants because they don't cool down. They don't fade away like white dwarfs or slowly lose structure like neutron stars. Instead, they consume anything that comes too close, growing larger over time. But here's the thing, in a universe where nothing is left but black dwarfs and other dead stars, there's not much left to consume. Eventually, black holes will stop growing, left to exist in isolation. The only thing that can affect them at this point is something called Hawking radiation, a slow, almost imperceptible leakage of energy that causes black holes to lose mass over time. And just like black dwarfs, this process takes an unimaginable amount of time. For a typical black hole to evaporate completely via Hawking radiation, we're talking about a timescale of 10 to the power of 100 years. That's a 1 followed by 100 zeros. A number so big that even our entire human history is nothing compared to it. But eventually even black holes will disappear. One by one, they'll radiate away their last bit of mass, vanishing in a final burst of energy. And when the last black hole evaporates, the universe will be left with nothing but black dwarfs, cold, dark, and silent. This will be the beginning of what physicists call the dark era, a time when even the last remnants of active processes have ceased. There will be no more fusion, no more gravitational interaction strong enough to cause major events, no new structures forming, just a vast, empty expanse dotted with black dwarfs, drifting endlessly. But even then, the story isn't quite over. Because the thing about black dwarfs is that, while they may seem completely inert, they're not technically eternal. Given an even longer timescale, numbers so huge they make the age of the universe so far seem insignificant, quantum mechanics might come into play. And this is where things get really strange. Remember, black dwarfs are supported by electron degeneracy pressure, the same quantum rule that prevents atoms from being crushed into oblivion. But quantum mechanics has another rule, one called quantum tunneling. It's an effect that allows particles to randomly, spontaneously shift states, even when it seems physically impossible. And in a truly long-lived universe, black dwarfs could experience this effect on an astronomical scale. Over an unfathomable period of time, protons, the fundamental building blocks of atoms, might start to decay. This is a theoretical process known as proton decay, which hasn't been observed yet but is predicted by some physics models. If it happens, then eventually, every single black dwarf in existence will begin to break down. Now, let's put this into perspective. We're no longer talking about trillions of years. We're not even talking about quadrillions or quintillions. The timescale for proton decay in some models is 10 to the power of 34 years. That's a number so huge it makes the entire history of the universe look like a blink of an eye. And if those models are correct, then, given enough time, black dwarfs won't be permanent after all. They'll slowly dissolve, their atoms literally falling apart. What will remain after that? Only elementary particles, barely interacting, drifting apart in an empty void. At this stage, the universe will have truly reached the end of its journey. There will be no structures left, no stars, no planets, no black dwarfs, not even black holes. Every bit of matter will have either decayed or been stretched so thin that it no longer forms anything recognizable. This is what physicists call the heat death of the universe, the point where entropy reaches its maximum and no more usable energy remains. It's the ultimate stillness, the final fate of everything we know. But here's the million-dollar question: is this truly the end? Is there any possibility that something could happen beyond this? It seems bleak, but some physicists speculate that even the heat death might not be the final chapter. One idea is that, over an almost incomprehensible timescale, quantum fluctuations, tiny, random blips in the fabric of space-time, could cause a new Big Bang. Essentially, out of the empty void, a tiny fluctuation could grow and expand into an entirely new universe, starting the cycle all over again. This is the idea behind something called the Big Bounce, or cyclic universe theory, the possibility that even after the longest night, a new dawn could eventually emerge. It's a controversial idea, one that isn't widely accepted as a certainty, but it raises an interesting possibility. What if black dwarfs, the supposed final remnants of stars, aren't the end of the story? What if, somehow, their remnants contribute to something new, a spark in the vast emptiness, leading to the birth of a universe we can't even imagine? And that's where the real mystery lies. We don't know what will happen after the last black dwarf fades away. We don't know if the universe will truly end in stillness or if, somehow, something new will emerge. All we know is that the journey from the fiery birth of stars to the cold silence of black dwarfs is just one step in the story of the cosmos. But that's the beauty of space. The deeper we look, the more questions we find. And black dwarfs, these hypothetical objects that don't even exist yet, are one of the biggest unanswered questions of all. Because they remind us of something profound. No matter how much we think we understand, the universe always has more mysteries waiting for us. The thought of a universe filled with black dwarfs, drifting in a cold, silent void, is almost too immense to comprehend. But what's even more mind-bending is the fact that we're talking about something that doesn't even exist yet. No black dwarfs have formed. Not a single one. The universe simply hasn't been around long enough for them to come into existence. That's how long this process takes. Longer than the entire history of the cosmos up until now. When we talk about black dwarfs, we aren't talking about something that will appear in 1,000,000 years, or 1,000,000,000, or even 1,000,000,000,000. We're talking about something so far into the future that our current understanding of physics might not even apply by the time they actually exist. But assuming our current models hold, what would these objects actually look like? We know they'll be cold, dense, and dark, almost impossible to detect because they won't emit any visible light. They won't be like the white-hot white dwarfs we see today, glowing with the last remnants of heat from their past. Instead, black dwarfs will be invisible against the backdrop of space, emitting only the faintest traces of infrared radiation, detectable only with incredibly advanced technology, if there's anyone left to even observe them. However, despite their darkness, black dwarfs would still be incredibly heavy. Remember, a white dwarf is already a degenerate object, meaning it's incredibly compact for its size. A white dwarf typically has a mass similar to that of the Sun, but it's squeezed into a volume no larger than Earth. When it becomes a black dwarf, its mass won't change, but it will have cooled to the point where it no longer radiates light or heat. So imagine a massive ball of carbon and oxygen, dense beyond imagination, floating through the void, utterly motionless, surrounded by nothing but the empty vacuum of space. But here's where things get even stranger. Scientists believe that, given enough time, chemical reactions might still take place inside black dwarfs. Right now, white dwarfs are hot enough that their interiors are fluid or even semi-liquid, but as they cool into black dwarfs, their matter will crystallize. Some physicists suggest that, deep inside these objects, the cooling process will cause their carbon atoms to arrange into something familiar, a gigantic diamond. Yes, an entire dead star, essentially transformed into a planet-sized diamond floating through an empty universe. This isn't just speculation either. In 2004, astronomers discovered a white dwarf about 50 light-years away in the constellation Centaurus. Based on its temperature and age, scientists estimated that its interior had already begun crystallizing, turning into something that strongly resembles a massive diamond. They even gave it a name: Lucy, after the Beatles' song Lucy in the Sky with Diamonds. But if a white dwarf like Lucy is already beginning this transformation, then black dwarfs, many trillions of years in the future, will almost certainly be fully crystallized. Imagine a universe filled with thousands of these colossal diamond-like remnants, drifting endlessly in darkness. But there's another strange possibility. Could black dwarfs do anything? Are they just lifeless objects, or could they still generate energy in some way? The answer might be surprising. Some scientists have proposed that, under extremely rare conditions, nuclear fusion could still happen inside black dwarfs. Not in the traditional sense, where hydrogen atoms fuse into helium, but through something called quantum tunneling. This is a bizarre effect of quantum mechanics that allows particles to bypass normal physical barriers, meaning that even in the cold, dead core of a black dwarf, some fusion reactions could still occasionally take place. Now, don't get too excited. This wouldn't be enough to reignite the star or bring it back to life. But in a universe where almost nothing is happening, even the faintest trace of fusion is fascinating. It means that, even in the farthest reaches of time, some tiny flickers of energy might still exist. It wouldn't be light we could see, and it wouldn't be heat we could feel, but on an atomic scale, tiny reactions could still be occurring, defying the complete stillness of the universe's dark era. And if we take this idea further, we have to ask, what happens when black dwarfs start to decay? We already mentioned the possibility of proton decay, where the fundamental building blocks of atoms might eventually disintegrate. If this process happens, then black dwarfs themselves won't be permanent. They will slowly break down, atom by atom, until there's nothing left. This would take an unimaginable amount of time, far beyond even the lifetime of black holes. But it means that, ultimately, black dwarfs might not be the final stage of the universe after all. So let's imagine what this would look like. The last black hole has evaporated, leaving only black dwarfs behind. The universe is cold, dark, and lifeless. But over the course of 10 to the power of 100 years, 10 to the power of 150 years, 10 to the power of 200 years, these dead stars begin to break down. They don't explode, they don't collapse, they don't vanish in a dramatic flash of energy. Instead, they simply dissolve, their particles drifting apart into the vast emptiness of space. One by one, the last remnants of the cosmos fade into nothingness, leaving behind only a thin, barely detectable sea of stray electrons, neutrinos, and photons. At this point, the universe will have reached true heat death. There will be no remaining sources of structure, no interactions, no energy gradients, just a featureless, infinite void. And yet, some physicists suggest that this still might not be the end. As mind-boggling as it sounds, some theories predict that, given enough time, quantum fluctuations could cause a new Big Bang to emerge from the chaos, restarting the cycle all over again. If that happens, then black dwarfs, these quiet, frozen remnants of long-dead stars, might have played a role in setting the stage for a future universe we can't even begin to imagine. But here's the real kicker: all of this is speculation. We don't know if proton decay is real. We don't know if black dwarfs will truly be the last objects in existence. We don't know if the universe will end in silence, or somehow reset itself. Black dwarfs represent one of the greatest unknowns in physics, not because we don't understand their formation, but because we don't know what happens after them. They are the final question mark in the story of the cosmos, the last mystery that even science struggles to answer. And maybe that's what makes them so fascinating. Right now, we live in an era of light, of energy, of constant movement. But one day, all of this will end. One day, everything we know will fade away, leaving behind only these dark, silent objects drifting in the void. They are the future of the universe, a future so distant that it almost seems irrelevant to us now. But in the grand scheme of time, they remind us of something profound. Nothing lasts forever, not even stars. And yet, as long as there are mysteries like black dwarfs left to unravel, the quest for understanding will never truly end. The universe may one day go dark, but our curiosity will always burn bright. The idea of a universe filled with black dwarfs, drifting endlessly in a sea of nothingness, raises some of the most profound questions about the fate of existence itself. If all the stars eventually fade, if all sources of heat and light are extinguished, then what does that mean for the very nature of reality? Does time still have any meaning when there is nothing left to change? Does space still matter when there is nothing left to occupy it? These are the kinds of questions that black dwarfs force us to confront, not just as scientists, but as beings trying to comprehend our place in the grand timeline of the cosmos. To understand just how staggering the timeline of black dwarf formation truly is, we need to revisit the concept of stellar evolution. The Sun, for instance, has been shining for about 4.6 billion years, and it is expected to continue doing so for another 5 billion years before expanding into a red giant and then collapsing into a white dwarf. At that point, it will still be radiating away heat, but it will take trillions of years before it cools enough to become a black dwarf. This is such an incomprehensibly long time span that, by the time it happens, our galaxy as we know it may no longer exist in any recognizable form. The Milky Way itself is likely to collide with the Andromeda Galaxy in about 4.5 billion years, creating an entirely new galactic structure. If intelligent civilizations somehow survive until then, they will witness the transformation of our night sky into something entirely unrecognizable. But even that event is insignificant compared to the timescales involved in the cooling of white dwarfs. By the time the first black dwarfs form, every galaxy we see today will have been torn apart by gravitational interactions, their stars either ejected into the void or consumed by supermassive black holes. In this distant era, black holes will dominate the universe, slowly consuming whatever matter remains. Over the course of trillions upon trillions of years, these black holes will evaporate through a process known as Hawking radiation, losing mass particle by particle until they completely vanish. At that point, only the black dwarfs will remain. This will be the beginning of what physicists call the degenerate era, a time when the only objects left in the universe are these dark, frozen remnants of once bright stars. The physics of black dwarfs is something we can only predict based on our current understanding of stellar remnants. We know that white dwarfs are already incredibly dense due to the forces of electron degeneracy pressure, which prevents them from collapsing under their own gravity. A black dwarf will be just as dense, but completely cold, meaning that its atoms will no longer be moving in any significant way. This leads to another fascinating possibility: the idea that black dwarfs might be among the most stable objects in the universe, lasting longer than anything else before ultimately decaying. But decay into what? If protons do decay, a hypothesis that is still unproven, then black dwarfs won't be eternal. Instead, they will very slowly disintegrate over a timescale of at least 10 to the power of 34 years, releasing energy in the form of subatomic particles. If this happens, then even the black dwarfs won't be the final stage of existence. They, too, will eventually fade into nothing, leaving behind only a universe filled with stray electrons and radiation at temperatures barely above absolute zero. However, if protons do not decay, then black dwarfs could theoretically last forever. This would mean that long after black holes have evaporated and the universe has reached its final, frozen state, black dwarfs will still be drifting through the void, unchanged. In this scenario, they become the last physical remnants of the universe, silent, dead, and unobservable in any meaningful way. The thought of a future where nothing moves, nothing emits light, and nothing changes is one of the most haunting predictions of modern cosmology. It forces us to consider the possibility that time itself might lose its meaning. If there is no interaction, no transformation, and no energy exchange, then what does it even mean for time to pass? Some physicists suggest that, at this point, the universe will effectively be frozen in an eternal state of stagnation. Others argue that quantum effects could still lead to rare fluctuations that might eventually trigger new events, perhaps even a new Big Bang, restarting the cycle of cosmic history all over again. But this is where the limits of our knowledge become clear. We don't know what the true final fate of the universe will be. Black dwarfs represent one of the most speculative and distant concepts in all of astrophysics. They exist purely as a mathematical prediction, a logical consequence of stellar evolution that is so far beyond our current observational reach that they might as well be science fiction. Yet, the fact that they must exist, assuming our understanding of physics is correct, makes them one of the most intriguing mysteries of all. They are the ghosts of stars that have yet to die, remnants of a future that is so distant it is almost incomprehensible. In many ways, they are the ultimate paradox, objects that are simultaneously inevitable and yet completely unobservable, forming the very last chapter in the history of the cosmos. And so, we are left with a question that may never be answered in our lifetimes. What will become of black dwarfs in the true end of time? Will they persist indefinitely as the last remaining matter in a universe that has gone completely dark? Or will they, too, eventually fade, dissolving into the void as the cosmos reaches its final, unknowable state? For now, all we can do is speculate. But the mere fact that we can ask these questions, that we can even conceive of a future so distant and so strange, is a testament to the power of human curiosity. The universe may one day grow cold, but as long as we are here to wonder about its fate, the search for understanding will never truly end. The thought of a universe where black dwarfs are the last surviving objects is both fascinating and unsettling. If we assume that protons do not decay, these frozen stellar remnants could persist for an unfathomable amount of time, drifting endlessly through an increasingly empty cosmos. In such a scenario, they would be the final survivors in a universe that has exhausted all its energy sources. But what would that existence even look like? A black dwarf emits no light, no heat, and no detectable radiation. It would be completely invisible to any observer, if such an observer could even exist at this stage of cosmic evolution. These objects would be the coldest, most inert bodies imaginable, lacking any form of energy output or interaction with their surroundings. But what happens if protons do decay? If that hypothesis is correct, then even black dwarfs are not truly eternal. Over an unimaginable timescale, their fundamental building blocks, the protons and neutrons that make up their atoms, would begin to break down into smaller subatomic particles. The black dwarfs would gradually disintegrate, releasing tiny amounts of radiation as they dissolve into nothingness. This process would take an amount of time so vast that it dwarfs even the current age of the universe. We're talking about a period of at least 10 to the power of 34 years, possibly much longer. By this point, not only would all galaxies have long since ceased to exist, but even black holes would have evaporated through Hawking radiation. If black dwarfs do decay, then they represent one of the final physical stages of the universe before it reaches the ultimate end, what cosmologists call the heat death. In this scenario, all matter eventually breaks apart, leaving behind a universe filled only with diffuse, low-energy radiation at a temperature barely above absolute zero. There would be no structures, no interactions, and no possibility of new formations. Time itself might lose meaning, as nothing would be changing in any meaningful way. This would be the absolute end of everything, unless, of course, something unexpected happens. One of the more speculative ideas in theoretical physics is that quantum fluctuations could still occur in this seemingly lifeless void. The idea is that even in a universe that has reached maximum entropy, there could still be rare, spontaneous fluctuations in the quantum vacuum. In extremely rare cases, so rare that it would take far longer than the age of the universe, such a fluctuation might create a new Big Bang. This would essentially restart the entire cosmic cycle, leading to the birth of a brand new universe from the remains of the old one. If this is the case, then black dwarfs may not be the final stage of existence, but rather the precursors to an entirely new reality. Another mind-bending possibility is the concept of Boltzmann brains. According to this idea, in a universe that has reached a state of maximum entropy, random quantum fluctuations might, given enough time, spontaneously create self-aware entities out of the chaos. These hypothetical beings, known as Boltzmann brains, would briefly exist in the void before disappearing again. If this idea holds any truth, then the long-dead universe might still occasionally produce conscious observers, even when there is no longer any structure or life in a traditional sense. But even if these speculative ideas never come to pass, black dwarfs remain one of the most intriguing concepts in astrophysics. They represent a glimpse into a future so distant that it challenges our ability to comprehend time itself. The mere fact that we can predict their existence, despite never having observed one, is a testament to the power of theoretical physics. And while we may never see a black dwarf with our own eyes, their inevitability raises profound questions about the ultimate fate of everything we know. As we consider this dark, frozen future, we are left with a sense of awe at the sheer scale of cosmic time. The universe as we know it is still young, only about 13.8 billion years old. Compared to the timescales required for black dwarfs to form, this is practically nothing. We exist in an era of light, where stars still burn and galaxies still shine. But one day, all of this will fade. The stars will die, the galaxies will disperse, and all that will remain are these silent, invisible remnants. And so, we are left with a haunting thought: if black dwarfs will one day fill the universe, and if no observers exist to witness them, does their existence even matter? Is a universe that is cold, dark, and empty still a universe at all? Or is it simply the end of everything? Perhaps we will never know. But as long as we are here to ask these questions, to ponder the mysteries of the cosmos, and to seek understanding in the face of the unknown, the spirit of discovery will never fade. The universe may grow dark, but our curiosity burns on. The fate of black dwarfs is intertwined with the most fundamental mysteries of the universe. If protons are truly stable, then these stellar corpses could persist for eternity, drifting through an empty void where even black holes have long since evaporated. But if protons decay, then black dwarfs will eventually vanish too, releasing their particles into the cosmic nothingness. This leads us to an unsettling question: if everything eventually fades, then what, if anything, comes next? Some physicists speculate that the end of black dwarfs could mark the absolute end of time itself. In our everyday experience, time is defined by change, motion, interactions, cause and effect. But in a universe where all black dwarfs have decayed and nothing else can happen, time might lose all meaning. This would be a universe without events, without observers, without even the potential for something new to occur. It would be the closest thing to nothing that reality could ever reach. But not everyone agrees that this is truly the end. Some theories suggest that even in a universe of total entropy, strange things could still happen. Quantum mechanics allows for random fluctuations in even the most seemingly empty space. If these fluctuations are significant enough, they could trigger the spontaneous creation of new structures, new energy, or even an entirely new Big Bang. This raises the bizarre possibility that, even after the last black dwarf has decayed, the cycle of the cosmos might somehow start over again. This idea connects to the concept of the Big Bounce, a theory that suggests our universe is part of an endless cycle of expansion and collapse. Instead of ending in total heat death, the universe might one day contract back into a singularity, leading to another explosion and the birth of a new cosmos. If this is true, then black dwarfs are not the final end. They are simply one stage in an eternal process. However, another possibility is even stranger. What if the universe doesn't repeat, but instead spawns something entirely new? If black dwarfs decay into elementary particles and radiation, could those remnants eventually arrange themselves into something different, something we can't even imagine? Could the decay of the last black dwarf be the seed of a new reality, one governed by different physical laws? These ideas push the boundaries of what we can understand, but they remind us of one crucial fact: black dwarfs are not just a curiosity. They are a key to understanding the deepest questions about existence. They challenge us to think not just about the fate of individual stars, but about the ultimate destiny of the universe itself. Right now, we live in an age of light, in a universe filled with stars, galaxies, and energy. But we are only a tiny moment in an unimaginably vast timeline. Long after humanity is gone, long after even the most advanced civilizations have vanished, the slow march toward darkness will continue. Stars will burn out. White dwarfs will fade. And one day, the universe will belong to the black dwarfs, silent, invisible, and alone. But maybe, just maybe, the story doesn't end there. Maybe even in the darkest of times, something new can begin. And perhaps, in some far distant future beyond our comprehension, the universe will surprise us once again. The existence of black dwarfs, if they do form, represents the longest, slowest phase in the entire history of the universe. Everything we know about cosmic evolution has led to the moment where the last stars burn out, leaving only these frozen remnants behind. But the sheer timescales involved push the limits of human comprehension. We think in terms of years, centuries, and perhaps millennia. Even when we discuss the lifetime of stars, we talk about millions or billions of years. But black dwarfs exist on a scale so vast that it makes all of this seem like an instant. The transition from a white dwarf to a black dwarf takes longer than the current age of the universe, trillions upon trillions of years. This means that, even if our universe survives long enough for black dwarfs to exist, no living being will ever witness one. They are purely theoretical, predicted by our understanding of physics, but forever beyond our reach. To understand the staggering length of time we are dealing with, imagine compressing the entire history of the universe into a single year. In this analogy, the Big Bang occurs at midnight on January 1st. The first galaxies form in early February. Our Sun and Earth don't even exist until early September. The age of dinosaurs occurs around Christmas Eve, and humans don't appear until late on December 31st, in the last minutes before midnight. Now, consider that the formation of black dwarfs doesn't happen until trillions of years into the future. If we continue the analogy, black dwarfs wouldn't form until thousands of years after the calendar has ended. It is a timescale that stretches beyond imagination, making even the lifespan of entire civilizations seem like a flicker. But what would a universe filled with black dwarfs actually look like? The simple answer is darkness. Without stars, there is no natural source of light, no warmth, no energy actively being produced. The cosmos, once alive with the glow of countless galaxies, would be an abyss of frozen, invisible objects. Black dwarfs would drift silently through the void, unlit and undetectable. They would be colder than anything we've ever encountered, with temperatures barely above absolute zero. In such a universe, the concept of day and night would lose all meaning because there would be no light at all. The only way to detect a black dwarf would be by feeling its gravitational pull, if, of course, anything still existed to feel it. Yet even in this darkened universe, physics continues. Black dwarfs, though seemingly eternal, would still be governed by the slow but inevitable decay of matter. If protons are unstable, then black dwarfs are not actually the final stage of existence. Instead, they are just another step toward the true end. Over the course of unimaginable timescales, the individual atoms making up a black dwarf would begin to disintegrate. This process, known as proton decay, is purely theoretical, but if it happens, it means that even the most resilient forms of matter will eventually cease to exist. Proton decay is predicted by some grand unified theories in physics, suggesting that given enough time, a single proton will eventually break apart into smaller particles, releasing tiny amounts of radiation in the process. The half-life for such a decay is estimated to be at least 10 to the power of 34 years, meaning that it takes an almost incomprehensible amount of time for even half of the protons in a given object to decay. But given enough time, trillions upon trillions of times longer than the current age of the universe, even black dwarfs will disintegrate. They will slowly fade, atom by atom, into a stream of fundamental particles that dissipate into the void. If this happens, then even the last remnants of stellar evolution will be erased. The universe will become a thin mist of radiation and elementary particles, stretching infinitely in all directions. No solid structures will remain. No objects will form. No events will occur. At this stage, the cosmos will have reached what is known as the heat death, or the Big Freeze. All energy will be evenly distributed, and no further work can be done. This is the final equilibrium state, a universe in which nothing changes, because there is nothing left to change. However, some physicists argue that even this is not truly the end. Quantum mechanics suggests that empty space is not completely empty. It is filled with random fluctuations of energy at a microscopic level. Given an infinite amount of time, strange things could still happen. There is a theoretical possibility that, in an otherwise lifeless void, a sudden quantum fluctuation could produce a new burst of energy, triggering the formation of a new universe. This is known as the idea of a Boltzmann fluctuation, a spontaneous emergence of order from chaos, simply because, over infinite time, even the most improbable events must eventually happen. If this is true, then perhaps black dwarfs are not the final stage, but rather the final phase before a cosmic rebirth. The last black dwarf could eventually decay, its particles dissolving into the empty abyss, only for something completely new to emerge in the far distant future. Could the remnants of these long-dead stars seed the beginning of something we can't even comprehend? Could they serve as the building blocks of a new universe, governed by new laws of physics? We don't know. But what we do know is that black dwarfs represent a cosmic milestone, the final echoes of the universe's past before it steps into a future of complete uncertainty. When we think about the far future, it's easy to feel insignificant. The vast stretches of time make everything we do seem small, almost meaningless. Our entire history, our entire species, everything we have ever built or imagined will be long forgotten before black dwarfs even begin to form. The universe will continue on, indifferent to our existence. But perhaps, instead of feeling insignificant, we should feel privileged. We live in a brief, golden age of the cosmos, an era filled with light, energy, and complexity. We exist at a time when stars still shine, when galaxies still dance across the night sky. We have the ability to look up and wonder, to question, to seek answers. And maybe that is what truly matters. Even if black dwarfs are the end, even if the universe eventually fades into silence, the fact that we were here to think about it, to understand it, and to tell its story is something remarkable. The cosmos may go dark, but as long as we are here, we can illuminate its mysteries with our curiosity. And perhaps, in some distant future, when the last embers of creation flicker out, something new will rise to take its place. Because if there is one lesson the universe has taught us, it is that nothing truly stays the same forever. If black dwarfs are indeed the last remnants of stellar evolution, then they serve as the final markers of a universe that once burned bright with energy and creation. They are the echoes of an age long past, drifting through a void that has been stripped of all the dynamism that once defined it. But while we can theorize about their existence, their exact nature remains a mystery, shrouded in the depths of time that even our most powerful models struggle to predict. They are objects that will never be observed, never be measured, and never be studied firsthand. They are ghosts of a future so distant that it might as well be another reality entirely. The concept of a black dwarf challenges our perception of time itself. As human beings, our understanding of time is rooted in cycles, day and night, the changing of seasons, the ticking of a clock. Even when we think in terms of history, we measure time in centuries, occasionally millennia. But black dwarfs exist on timescales that render all of this meaningless. 1,000,000,000,000 years is an absurd length of time compared to our experience, yet it is still only a fraction of the lifespan of a black dwarf. If we were to measure time from the birth of the first stars to the formation of black dwarfs, it would be like comparing the blink of an eye to the entire age of the universe. This makes black dwarfs some of the most elusive and alien objects ever conceived, not because they are physically complex, but because they exist on a plane of time that we simply cannot relate to. The idea of black dwarfs also raises philosophical questions. If no one will ever see one, if they will never interact with anything else in the cosmos, do they even matter? Do they have significance in a universe that has long since gone silent? These questions force us to confront the nature of existence itself. If a tree falls in a forest and no one is around to hear it, does it make a sound? If a black dwarf exists in a universe where there are no observers, no interactions, no consciousness, does it truly exist in any meaningful way? But maybe significance isn't about being observed. Maybe it isn't about serving a purpose in some grand cosmic narrative. Maybe black dwarfs, like everything else in the universe, simply exist because they must. They are the inevitable result of physics unfolding over unimaginable timescales. They are the final chapter in the life cycle of stars, playing out long after the rest of the cosmos has faded away. And in their own way, they are a testament to the unyielding nature of time itself, a reminder that no matter how grand, how powerful, or how brilliant something may be, nothing lasts forever. Yet even in the depths of this unimaginable future, the story may not truly end. The universe is not static. It is governed by forces that continue to act, even in the absence of light, energy, and structure. Black dwarfs, though seemingly eternal, are still subject to the fundamental laws of physics. If protons decay, then black dwarfs will eventually dissolve into a fine mist of subatomic particles. And if they do not, then they will simply remain, drifting endlessly in a darkened void, waiting for something, anything, to disrupt their eternal stillness. But what if the universe itself undergoes a transformation? What if, after an unfathomable stretch of time, new physics takes hold, reshaping the very fabric of reality? There are theories that suggest that the constants of nature might not be fixed, that over extreme timescales, the laws that govern the cosmos could shift in ways we cannot predict. If this is true, then black dwarfs might not be the final state of matter, but rather a stepping stone towards something we cannot even conceive. Some physicists propose that vacuum decay, a process in which space itself could suddenly shift into a lower energy state, could one day rewrite the entire structure of the universe. If this occurs, black dwarfs would not just disappear, they would be completely erased, replaced by an entirely new reality governed by new laws, new forces, and new possibilities. In this scenario, the universe does not simply fade away. It transforms into something entirely different, something beyond our imagination. The existence of black dwarfs is tied to the deepest questions in cosmology, questions about time, entropy, and the ultimate fate of everything. But these questions are not just about the far future, they also force us to think about our present. What does it mean to exist in a universe that is destined to go dark? What does it mean to be alive at a time when stars still shine, when energy still flows, when complexity is still possible? Perhaps the true significance of black dwarfs is not in their future existence, but in what they teach us about the present. We are fortunate to live in an era where the universe is active, where there is still time for discovery, for thought, for wonder. The cold, dark future of the cosmos serves as a reminder that we exist in a fleeting moment of brilliance, a brief flash of complexity in a universe that will eventually settle into simplicity. And maybe, just maybe, this realization gives our existence more meaning, not less. Because if we are among the only beings who will ever think about these things, then that means it is our responsibility to understand, to explore, and to make the most of the time we have. The universe may one day go silent, but while we are here, we have the chance to tell its story, to marvel at its wonders, to seek its truths, and to embrace the incredible reality that, for a brief moment, we were here to witness it. But what if black dwarfs are not truly the end? What if, even in the deepest future, some remnant of cosmic activity remains? Could there still be a way for new physics to emerge, new structures to form, or even, against all odds, a rekindling of light in the vast and silent void? This question leads us to one of the strangest possibilities in modern physics: the idea that even in an era of darkness, quantum mechanics might still play a role. While classical physics predicts a lifeless, frozen cosmos filled with drifting black dwarfs, quantum physics introduces the idea of spontaneous fluctuations, tiny, random events that occur even in the most empty and lifeless regions of space. Given an infinite stretch of time, could something extraordinary emerge from these fluctuations? One speculative idea is the concept of a Boltzmann brain, a hypothetical self-aware structure that could emerge purely by chance due to quantum fluctuations. If the universe exists for an incomprehensibly long period, then the probability of particles randomly assembling into a thinking entity, however small, is not zero. Over an infinite timeline, even the most improbable events could become inevitable. Could black dwarfs, in some bizarre way, serve as the backdrop for the birth of these strange, fleeting minds? But perhaps the real mystery of black dwarfs is not just their ultimate fate, but what their very existence tells us about the nature of time itself. We often think of time as a constant, moving forward in a linear fashion, but black dwarfs force us to reconsider. If they exist on timescales that stretch trillions upon trillions of years, how do we even begin to grasp what that means? Is time truly a universal property, or is it something that only has meaning when there is something to measure it against? And what happens if the very fabric of the universe changes over such vast timescales? Some theories suggest that the fundamental constants of nature, things like the speed of light or the charge of an electron, might not be fixed, but could shift over extreme periods. If this is the case, then black dwarfs could experience changes that we cannot even predict. Could they collapse under their own weight? Could they ignite once more under an altered set of physical laws? Could they transition into an entirely different state of matter that we have never observed? There is also the possibility of cosmic rebirth. While black dwarfs represent the end of normal stellar evolution, they may not be the end of all cosmic activity. Some models of the universe suggest that even after the last stars have faded, new structures could still emerge under the right conditions. If the universe undergoes a big bounce, rather than a heat death, it is possible that these black dwarfs could be recycled into new matter, fueling the birth of stars in a completely new era of cosmic evolution. Alternatively, if the universe continues expanding forever, reaching a state where energy is so stretched that no new interactions can occur, then black dwarfs will remain, drifting endlessly in a cosmic graveyard. But even in this scenario, there may be surprises. Some speculative theories suggest that new forms of exotic matter could arise from extreme low-energy conditions. If this is true, then black dwarfs might one day become the seed of something new, something we cannot even begin to imagine. The reality is that black dwarfs exist at the limits of our understanding, in a future so distant that our very ability to predict it becomes questionable. They challenge everything we know about the universe, forcing us to rethink not only the fate of stars but the nature of time, entropy, and cosmic evolution itself. Perhaps, in the grandest sense, black dwarfs are not just the remnants of dead stars, but the ultimate test of our understanding of physics. They represent the point at which our knowledge breaks down, where we must confront the unknown and acknowledge that some answers may remain forever beyond our reach. And yet, this mystery itself is what makes them so compelling. Because as long as we are here, as long as we can think and wonder, the universe remains alive, not just through the burning of stars, but through the spark of curiosity that drives us to seek the answers, no matter how far away they may be. If black dwarfs represent the final stage of stellar evolution, then they are more than just remnants of dead stars. They are scattered across a universe that has grown silent. They tell us that everything we see today, from the brilliant galaxies to the smallest stars, will eventually be reduced to nothing more than cold, dark husks, slowly radiating their last vestiges of heat into the void. But the true weight of their existence comes not just from what they are, but from what they imply about the nature of time itself. When we talk about black dwarfs, we are no longer dealing with time as we understand it. The age of the universe, from the Big Bang to the present moment, is just under 14 billion years. That is an almost unfathomable stretch when measured against the human lifespan, yet it is barely the opening act in the story of black dwarfs. To even begin forming, white dwarfs must take hundreds of trillions of years to cool down. By the time black dwarfs exist, the entire age of the universe as we know it will have been repeated millions of times over. Every star that has ever shone, every galaxy that has ever spun, every civilization that has ever arisen, all of it will be ancient history before a single black dwarf even comes into being. This forces us to ask an unsettling question: does time still have meaning when there is nothing left to measure it? Today, we track time by the motion of planets, the ticking of atomic clocks, the orbits of stars. But in the era of black dwarfs, there will be no planets left, no orbits, no light. The universe will be a featureless abyss, and the only remaining events will unfold so slowly that they might as well not be happening at all. What does it mean to say that a black dwarf will take trillions of years to radiate away its energy when there is no one left to observe those trillions of years? When the last black dwarf finally fades, does it truly disappear, or does the concept of disappearance lose all meaning when nothing else remains to contrast against it? And yet, even in this bleak, lifeless future, the universe will not be entirely still. If the laws of physics remain as we understand them today, then the very structure of matter itself is not permanent. Some theories suggest that protons, the fundamental building blocks of atoms, may eventually decay over unimaginably long timescales. If this is true, then black dwarfs will not last forever. Over eons beyond human comprehension, the atoms that make up their structure will slowly disintegrate, dissolving into a fine mist of subatomic particles. Even the most stable elements, the very matter that composes the stars and planets, will ultimately break down. But if protons do not decay, then the black dwarfs will persist, becoming the longest-lasting objects in the entire universe. They will outlive everything: the stars, the galaxies, even the cosmic background radiation that still echoes from the Big Bang. They will drift through a universe so empty and so stretched that even quantum interactions become rare. Over quadrillions, quintillions, and even sextillions of years, black dwarfs will remain, locked in a perpetual stasis, until some force, be it proton decay, a change in the laws of physics, or the collapse of the universe itself, finally erases them. Yet even if we assume that black dwarfs are the final state of matter, the fundamental question remains: is the universe truly heading for an absolute end? The prevailing theory suggests that we are moving toward a heat death, a state in which all energy is evenly spread out, and no useful work can be done. But what if there is another fate waiting beyond the horizon of our understanding? One possibility is that the universe is not truly static, even in the deep future. Some models propose that the vacuum of space itself is not entirely stable. If space is in a false vacuum state, then it could suddenly decay into a lower energy state, triggering an event that would rewrite the entire cosmos. This so-called vacuum decay could erase all existing structures in an instant, including black dwarfs, and replace them with an entirely new universe governed by different physical laws. If this happens, then black dwarfs would not be the final chapter in cosmic history, but merely the transition point into something else, something we cannot even begin to predict. Another possibility is that, given an infinite amount of time, random quantum fluctuations could generate entirely new structures. In an eternally expanding universe, even the most unlikely events become inevitable given enough time. Some physicists argue that, through sheer randomness, particles could assemble into new stars, new galaxies, or even new forms of life. This would mean that black dwarfs, while enduring for unimaginable spans of time, would not be the final objects in the universe but simply another phase in an endless cycle of cosmic rebirth. But perhaps the most mind-bending possibility is that the universe itself may one day be reborn in a Big Bounce scenario. If space-time is not infinitely expanding but instead undergoes cycles of collapse and rebirth, then black dwarfs may not be the last relics of a dying universe, but rather the building blocks of a new one. In this view, the vast emptiness of the late universe is not the end but the beginning of something entirely new, a return to chaos, heat, and creation. If this is the case, then black dwarfs are not merely the remnants of dead stars, but the seeds of a future we cannot yet comprehend. Their slow radiation of energy, their gradual disintegration, and their eternal drift through the void may all be necessary steps in a process that leads to the next iteration of the cosmos. It is possible that, just as stars gave birth to planets and life, black dwarfs could eventually give birth to something else, something beyond our understanding. Ultimately, black dwarfs remind us of the limits of our knowledge. They exist at the edge of what we can predict, in a future so distant that our current models may not even apply. They force us to confront the reality that the universe is far stranger, more mysterious, and more unpredictable than we can possibly grasp. And yet, this is precisely what makes the search for understanding so important. Even in the face of an inevitable end, even in a universe that will one day grow cold and dark, the fact that we can ask these questions, that we can seek these answers, gives our existence meaning. Because in the grand scope of time, we are here for just the briefest instant. The light of our civilization, of our entire species, is a fleeting spark in the darkness. And yet, while we are here, we have the ability to look forward, to imagine the future, and to ponder the fate of the cosmos itself. The universe may one day fade into silence, but as long as there are minds to wonder, to explore, and to seek the truth, that silence will never be absolute. Even in the vast emptiness of the distant future, there remains one final, almost paradoxical mystery: the role of consciousness itself. If black dwarfs mark the end of all stellar activity, if the universe truly fades to nothing but cold, lightless remnants, then does that mean thought, awareness, and intelligence must also come to an end? Is the death of the stars also the death of all meaning, or could there be some way for consciousness to persist even when the physical universe has gone dark? This question forces us to reconsider the fundamental nature of reality. If intelligence is merely an emergent property of physical systems, if it arises from the interactions of atoms, neurons, and energy, then the death of all energy-producing structures would seem to spell the inevitable extinction of thought itself. Without stars to power civilizations, without heat to drive metabolic processes, without energy to sustain computation, what could possibly remain? Would the last mind to exist simply flicker out, alone in an infinite void, as the last source of heat finally dissipates? But what if intelligence is not entirely bound to the constraints of matter? What if the mind, or at least the potential for thought, exists as something more fundamental? Some physicists have suggested that information itself is a fundamental building block of reality, as important as space, time, or matter. If this is true, then the end of all energy may not necessarily mean the end of intelligence. It may simply mean that intelligence must take on a different form. One possibility is that, before the last civilizations die out, they could encode their knowledge, their consciousness, and even their very essence into the fabric of space itself. Some speculative theories propose that advanced civilizations may one day discover ways to manipulate the underlying quantum structure of reality, embedding information into the vacuum of space in such a way that it remains accessible even in a universe where no energy remains. If this were possible, then black dwarfs would be storage devices, archives of all that ever was, waiting to be rediscovered by some future intelligence beyond our comprehension. Another, even stranger possibility is that intelligence could transcend the need for physical existence entirely. If reality is ultimately governed by information, then perhaps minds could continue to exist in some abstract, non-physical form, persisting as patterns of information even when no energy remains to sustain them. This would mean that the final phase of the universe is not a state of pure emptiness, but a state of pure thought, a cosmic afterlife, where the distinction between existence and non-existence becomes meaningless. But even if intelligence cannot survive the death of the universe, even if black dwarfs mark the true end of everything, there is still one last, unsettling question: what happens next? Because while the timeline of black dwarf formation is unimaginably long, it is not infinite. Eventually, one way or another, the black dwarfs will be gone. Whether through proton decay, quantum tunneling, or some yet unknown process, they will fade, just as everything else has faded before them. And then what? Does the universe simply exist forever in a state of perfect emptiness, with no matter, no energy, and no possibility of anything ever happening again? If so, then that would be the true, final death, not just the death of stars, not just the death of life, but the death of all potential. A universe that continues to exist but in which absolutely nothing ever happens again would be, in many ways, more terrifying than an outright collapse. It would be a state of eternal silence, without even the faintest whisper of change to break the monotony. Or could something else take place? Some cosmologists have speculated that, in an infinitely stretched, empty universe, new quantum fluctuations might eventually spark something new. Over absurdly long timescales, random fluctuations in the vacuum of space could generate new pockets of energy, new bursts of heat, perhaps even, in the most extreme case, an entirely new Big Bang. If this is true, then black dwarfs are not the end of the story, but merely the final remnants of one particular cycle of the universe. They would be the last traces of an old reality, left behind as the cosmos resets itself and begins anew. And if this is the case, then perhaps, in some unimaginable future, the universe will not be cold and lifeless forever. Perhaps new stars will be born, new galaxies will form, and new civilizations will rise, never knowing that they are living in a universe built upon the ashes of an older one. Perhaps this has already happened countless times before, with each cycle of reality forgetting the ones that came before it. If so, then black dwarfs are not truly the end, they are merely echoes of a past so distant that even time itself has forgotten it. So, as we look up at the night sky today, at a universe still teeming with light and energy, we are witnessing something rare and fleeting. The age of the stars will not last forever. The time will come when every star has burned out, when every planet has frozen, when every black hole has evaporated. But whether that is truly the end, or merely the transition to something else, remains the greatest mystery of all. The idea that the universe could eventually reset itself, that the death of black dwarfs is not the final chapter but merely a transition into something new, raises deep questions about the nature of existence itself. If time is cyclical, if reality can restart after an incomprehensible stretch of emptiness, then what does that say about everything that has ever lived, thought, or created? Would new stars in a reborn universe mean new life, new intelligence, and new civilizations? Or would they merely be hollow repetitions of what came before, with history doomed to play out the same way over and over again? And if the universe is not a cycle, if it truly has a final ending, then what was the point of it all? Was it simply a brief, brilliant flash of structure and order in an otherwise meaningless expanse of chaos? These are not just questions about physics, but about philosophy, about the nature of meaning itself. If black dwarfs are the final physical objects to exist before reality fades into complete emptiness, then they are more than just stellar remnants. They are symbols of the ultimate fate of everything that has ever been. Every story, every thought, every moment of joy or sorrow that has ever occurred is part of this cosmic timeline that eventually leads to them. The rise and fall of civilizations, the birth and death of galaxies, even the formation and destruction of entire clusters of matter, all of it is part of the same process that will one day leave only these cold, dead husks floating through an empty void. But does that mean that everything was pointless? That because it will all end, it never truly mattered? Or is it possible that meaning is not tied to permanence at all? This is the fundamental paradox of existence. We search for something eternal, something lasting, but everything we know is temporary. And yet, if black dwarfs and the heat death of the universe prove anything, it's that everything is part of a grander process, one that stretches across scales so vast that human minds can barely begin to grasp them. Maybe meaning isn't about how long something lasts, but about the fact that it existed at all. To put it another way, think about a star. A star does not last forever, and in the grand scheme of the universe, its lifetime is relatively short. And yet, for the billions of years that it shines, it is the source of warmth, of light, of energy that allows planets to form, that allows life to emerge. It may not last, but that does not mean it is insignificant. And if the brief flickering existence of a single star is still capable of giving rise to something as complex as life, then who is to say that our own fleeting existence, our own thoughts, struggles, and triumphs, are not just as important? And even if black dwarfs mark the end of all structure in the universe, even if nothing ever rises again from the ashes of existence, does that truly erase what came before? The universe does not have memory in the way that humans do, but for as long as it existed, the things that happened within it were real. That may be the only kind of meaning that matters. But still, there is the lingering possibility that black dwarfs are not the absolute end. Even if the universe does not restart itself, there may still be unknown physics at play, hidden rules of reality that we do not yet understand. Could there be forces beyond entropy that operate on unimaginable timescales? Could there be hidden dimensions where the laws of decay and heat-death do not apply? Some speculative theories suggest that if our universe is part of a larger multiverse, then even as it fades, other universes may still be thriving. And if that is the case, could something from one of those universes leak into our own, reigniting what seems to be lost? And then, there's one final, almost haunting question. If the universe does eventually reset, if new stars do form after an eternity of darkness, if new civilizations rise where there was once only empty space, would they ever be able to know that we existed? Would there be any traces, any echoes of what came before? Or would we be completely and utterly forgotten, as if we had never been here at all? Perhaps the only thing we can do, the only thing that truly matters, is to understand that we are part of this story, even if we do not know how it ends. The universe is still young. The stars still shine. And for now, at least, we are here to witness it. The thought of a universe in which black dwarfs are the last remaining objects, cold, dark, lifeless, and scattered across an endless void, raises one of the deepest existential questions of all. What is the purpose of a universe that no longer has anything happening within it? Every moment we have ever known, every event that has ever taken place, is built upon a universe in motion. From the birth of stars to the rise of galaxies, from the fusion of atoms in the hearts of suns to the formation of planets where life could emerge, everything we understand about reality is based on change. The fundamental forces of nature are what drive the universe forward, allowing structure to form, energy to flow, and complexity to arise. But if all of that eventually comes to an end, if the forces that have shaped the cosmos for billions of years reach a point where nothing new can ever happen again, then does the universe even truly exist in any meaningful way anymore? To say that something exists is to imply that it has some form of presence, some way in which it can be measured, observed, or interacted with. But if the future of the universe is nothing but black dwarfs, floating silently in a void where even time itself loses its meaning, then what does existence even mean in such a state? If nothing ever changes again, if no new events ever take place, then does time even continue to move forward? Or does it simply stop, frozen in an eternal moment where the very concept of before and after ceases to apply? This brings us to one of the strangest and most unsettling ideas in cosmology, the notion that time itself might one day stop existing. We tend to think of time as a constant, something that always moves forward no matter what. But in physics, time is not an independent thing. It is tied to the nature of space, energy, and entropy. As long as the universe has energy flowing through it, as long as there is something happening, time has meaning. But in a universe where nothing ever happens again, what role does time even serve? Some physicists suggest that in such a scenario, time may effectively end, not in the sense of disappearing, but in the sense that it no longer progresses. There would be no way to measure it, no changes occurring to mark its passage. In such a state, it would be impossible to even say how long the universe has existed, because long and short would no longer be meaningful concepts. This idea is profoundly unsettling, because it means that the death of the universe is not just the end of all matter, not just the fading of all energy, but the collapse of the very fabric of reality itself. If time no longer flows, then in a way, the universe stops existing in every way that matters. The black dwarfs that remain would not even be waiting for something to happen, because waiting implies the passage of time. They would simply be. But even in this seemingly final state, there is one last sliver of uncertainty, one last possibility that keeps the mystery alive. Because even if we assume that the universe reaches this ultimate, frozen, lifeless state, we still cannot be completely sure that it will stay that way forever. The reason is quantum mechanics. Quantum mechanics, the branch of physics that describes the behavior of particles on the smallest scales, is full of strange and counterintuitive phenomena. One of its fundamental principles is that nothing is ever truly static. Even in what we consider to be empty space, there are always tiny fluctuations of energy, random quantum events occurring at the smallest possible scales. These fluctuations are normally insignificant, but over absurdly long timescales that dwarf even the lifespan of black dwarfs, could they accumulate into something greater? Could a random fluctuation in the void of the dead universe one day spark the formation of something new? This idea, sometimes called quantum resurrection, is purely theoretical, but it suggests that even in a universe where all energy has faded away, the laws of physics might still contain the potential for change. It is possible, though unfathomably unlikely, that a spontaneous fluctuation could eventually give rise to a new burst of energy, perhaps even a new Big Bang. This would mean that black dwarfs are not the final remnants of a dead cosmos, but merely the last remnants of this particular iteration of the universe, with another one waiting to be born from the ashes. But if this is the case, if the universe is capable of restarting itself after an eternity of darkness, then we must confront a new and even deeper question. Has this already happened before? If new universes can arise from the remnants of old ones, then what we think of as the beginning of our universe may not have been the true beginning at all. There could have been universes before ours, stretching back into an infinite past that we will never be able to observe or comprehend. And if that is true, then the universe is not something that was born once and will die forever. It is part of a grander cycle, an eternal process of death and rebirth that has been unfolding for longer than we could ever imagine. This is where the mystery of black dwarfs takes on an almost poetic quality. If they are truly the last remnants of a universe in its final moments, then they are not just the end of a cosmic story, they are also a potential link to something beyond that end. Whether they mark the final death of everything, or the quiet transition to something new, remains unknown. But one thing is certain, as long as the universe still exists in any form, no matter how dark, cold, and empty it may seem, the mystery is never truly over. If black dwarfs are the last remnants of a dying universe, their significance extends far beyond just being cold stellar corpses. They represent something even more profound, the final evidence that anything ever existed at all. In a universe where every star has burned out, where every galaxy has faded into nothingness, and where all energy has been spread so thin that it no longer has the ability to do work, the only proof that anything ever happened in the cosmos lies in these frozen, inert objects drifting in an endless void. They are not just the remnants of stars. They are the remnants of history itself. But this raises an unsettling question. In such a state, does the universe even truly exist in any meaningful sense? Consider what existence means. In our everyday experience, we define reality by the things that happen within it. A tree exists not just because it has mass, but because it grows, absorbs sunlight, and interacts with its surroundings. A planet exists because it moves, it orbits, it has geological activity, and it is part of a larger system of gravitational interactions. Even a star, though it may seem like a fixed point of light in the sky, is defined by the nuclear fusion reactions occurring in its core. Everything we consider real is something that changes, something that is affected by time. But in a universe that has reached the final stages of heat death, where black dwarfs are the last things left, nothing changes anymore. Time still exists in theory, but with no events to mark its passage, it becomes functionally meaningless. It is a reality without motion, a cosmos where nothing happens, not because nothing is allowed to happen, but because there is no energy left for anything to happen. This state is not simply an empty universe. It is an unobservable one. If nothing can change, if no new interactions can take place, then even if these black dwarfs still exist, they have no way of making their existence known. They are isolated not just in space, but in the deeper sense of causality itself. The very concept of observation depends on something being able to affect something else. If a tree falls in a forest with no one around to hear it, it still makes a sound because sound is a physical phenomenon, a pressure wave that travels through the air. But in a heat-dead universe, if a black dwarf floats through an infinite void, does it exist in any way that actually matters? If there is no light, no gravity waves, no radiation, no movement, if no change is possible, then in what sense does anything in such a universe still happen? This is where physics crosses over into philosophy. If a reality exists in which nothing can change, then from any practical standpoint, it is no different from a reality that does not exist at all. It becomes a kind of paradox, a universe that technically exists but has no way of expressing that existence in any meaningful way. And if that is the case, then the final fate of the universe is not just one of darkness and emptiness, but of absolute silence. Not just the silence of space as we know it, where sound cannot travel due to the lack of air, but a deeper kind of silence, the silence of a reality that has lost all distinction between being and non-being. But even in this seemingly absolute ending, there is still a trace of uncertainty. Because while black dwarfs may mark the last physical structures of a dying universe, they may not be the absolute end of everything. As mentioned earlier, quantum mechanics introduces a layer of unpredictability even into the most seemingly stable systems. One of the strangest implications of quantum mechanics is that true emptiness does not exist. Even in the vacuum of space, there are always tiny fluctuations, random quantum events that cause brief appearances and disappearances of energy on microscopic scales. Normally, these fluctuations are insignificant, but over timescales that stretch into the incomprehensible, they might begin to add up to something more. One of the most speculative ideas in physics is that of quantum tunneling on a cosmic scale. In the same way that a subatomic particle can sometimes jump across a barrier it should not be able to cross, it is theoretically possible that, given enough time, a black dwarf could experience an event that causes it to collapse into something entirely new. This is not something that could happen in the lifetime of any ordinary star, or even within the entire current age of the universe. But in a timescale so vast that human minds struggle to comprehend it, even the most unlikely events can become inevitable. Imagine then that a black dwarf, one of the last remnants of the universe, suddenly collapses due to an improbable but possible quantum fluctuation. What happens next? Does it create a burst of energy? Does it collapse into a black hole? Does it cause some unexpected shift in the fabric of space-time? If such an event were to occur, would it be the last flicker of activity in an otherwise dead cosmos? Or could it be the spark of something new? Some physicists speculate that if a quantum event of sufficient magnitude were to take place within the vacuum of a heat-dead universe, it could trigger the formation of an entirely new universe. This is an idea related to the concept of false vacuum decay, the idea that what we think of as empty space might not be entirely stable, and that given enough time, it could undergo a fundamental transformation. In such a scenario, a random quantum fluctuation could create a new region of spacetime with different physical laws, different fundamental forces, and possibly even a new form of matter. If this were to happen, then black dwarfs would not be the end of everything, but rather the seeds from which a new universe could one day emerge. But if this is true, if the death of one universe inevitably leads to the birth of another, then we must confront an even greater mystery. Has this already happened before? Was our own universe born out of the ashes of a previous one? If black dwarfs and heat death are simply one phase in an eternal cycle, then what does that mean for us, for everything we know, for everything that has ever lived? Are we part of a grand cosmic pattern that stretches across an infinity of past and future universes? If so, then the universe is not a singular story with a clear beginning and end. It is an endless chain of rebirth and renewal, with each cycle emerging from the remains of the last. This idea forces us to rethink the very nature of existence. If reality itself is something that is continually born and reborn, then our place within it is both incredibly small and unimaginably significant. We may be fleeting, just like the stars that will one day fade into black dwarfs, but we are part of something far greater than ourselves. The atoms that make up our bodies were forged in the cores of ancient stars, stars that lived and died long before our planet even existed. And if the cycle of the universe continues, then those same atoms may one day be part of something new, something we cannot even begin to imagine. So perhaps the final fate of the universe is not an ending at all, but a transformation. Maybe black dwarfs are not just the last relics of a dying cosmos, but the quiet markers of a universe waiting for its next beginning. And if that is true, then the greatest mystery of all is not just how the universe will end, but what comes after. If the universe is destined to continue in an endless cycle, with black dwarfs merely serving as a transitional phase between one cosmos and the next, then we must reconsider our entire understanding of time itself. The human mind has evolved to comprehend time as a linear progression, a straight line from the past to the future. We measure moments, categorize history, and expect that every event must have a definite beginning and an ultimate conclusion. But what if time is not a line? What if it is a loop, a repeating cycle where the death of one universe inevitably gives birth to another? If this is true, then black dwarfs are not only relics of the past but precursors to something we cannot yet perceive. To grasp this idea fully, consider what time truly is. We experience time as a sequence of events, but time is fundamentally a property of the universe itself. The fabric of space-time, as described by Einstein's theories, is not separate from the matter and energy within it, it is shaped by them. This means that when all motion ceases, when black dwarfs become the last remaining structures in an entropic void, time itself may begin to break down. In such a state, time is no longer something that moves forward in any meaningful way. Without interactions, without events, without cause and effect, what does it mean for time to exist at all? This brings us to one of the most puzzling questions in modern physics. Could time itself eventually reset? If black dwarfs persist for unimaginable timescales, if they drift through an expanding void where nothing new ever emerges, then at some point, even they must reach the limits of their existence. Quantum physics suggests that no system can remain truly static forever. Even in a universe that has gone cold and dark, some form of change may still be possible, no matter how improbable. And if change can still happen, then perhaps the state of total cosmic stillness is not the final fate of everything, but merely a waiting period before something new begins. But what would this mean for black dwarfs? If time is cyclical, then black dwarfs could be the final objects of one universe and the first ingredients of another. Their extreme density and composition might make them the perfect candidates for triggering a new beginning under the right conditions. If a black dwarf, through quantum fluctuations or some yet undiscovered process, were to collapse into something far stranger, perhaps even into a new form of energy, then it might serve as the seed for the rebirth of the cosmos. This would mean that the last remnants of dying stars are not merely drifting toward oblivion, but carrying the potential for something greater. This possibility is both thrilling and terrifying. It suggests that even in the coldest, loneliest state imaginable, the universe may still hold the potential for renewal. But it also means that we, as intelligent beings, exist in a fleeting moment of this cycle, unaware of what came before and unable to see what will come next. If the universe is truly cyclical, then our existence is just one iteration of something that has happened countless times before, and will happen countless times again. The atoms that form our bodies may have been part of ancient stars in a past universe, and they may one day be part of entirely new structures in a cosmos we cannot even imagine. Yet, despite these possibilities, the nature of time remains one of the greatest unsolved mysteries in physics. We do not yet know if time is infinite, or if it has a beginning and an end. We do not know if black dwarfs are the true final stage of existence, or if they are merely a stepping stone towards something beyond our comprehension. What we do know is that black dwarfs, if they ever form, will be the quietest objects in existence, silent witnesses to the end of everything. And whether they mark the conclusion of all things or the beginning of something new remains one of the deepest cosmic enigmas we have yet to solve. If black dwarfs do hold the key to the ultimate fate of the universe, then understanding them means understanding the deepest truths about existence itself. But we are faced with a paradox. These objects do not yet exist. They are purely theoretical, predicted to emerge on timescales so vast that our own species, our entire civilization, and even the sun will be long gone before the first one ever forms. This raises an unsettling question: how can we ever confirm their existence? If black dwarfs are real but will not form for trillions upon trillions of years, are they even part of our reality in any meaningful way? This is where the nature of time itself becomes a challenge. The future is often spoken about as though it is something that simply hasn't happened yet, but relativity suggests something different. According to Einstein's theory of relativity, time is not an absolute flow but a dimension woven into the fabric of space itself. What we call the future already exists in a sense, just as the past still exists. If we had the right perspective, some way to see outside our normal experience of time, we might be able to view black dwarfs not as objects waiting to form, but as entities that are as real as the stars we see in the night sky today. This brings us to a deeply unsettling idea. If black dwarfs are an inevitable part of the universe's evolution, then in a way, they already exist in the structure of spacetime itself. The universe is constantly unfolding according to the laws of physics, and those laws dictate that given enough time, white dwarfs will cool into black dwarfs. But if time is simply a coordinate in a four-dimensional space, then black dwarfs are already part of reality. We just cannot access that part of time yet. This concept is similar to the way a road exists in its entirety even if you have not yet traveled to its end. The end of the road is real, you just haven't reached it. But this idea becomes even stranger when we consider the role of observation in physics. The famous Schrödinger's cat thought experiment suggests that in quantum mechanics, an event does not truly happen in a definite way until it is observed. Could it be that black dwarfs, despite being inevitable, do not truly exist in a meaningful sense until an intelligence, perhaps some future civilization, finds a way to detect them? If observation shapes reality, as quantum mechanics suggests, then does the very act of looking for black dwarfs in some distant future actually bring them into existence? This is one of the most mind-bending implications of modern physics. Yet, regardless of whether black dwarfs already exist, in some cosmic sense, they represent a truly alien state of matter. A black dwarf is more than just a cold remnant of a star. It is a structure composed of degenerate matter so dense that its properties defy normal experience. The electrons in a black dwarf are packed together in a quantum state unlike anything we can observe today. As a white dwarf cools, its electrons remain in a degenerate state, meaning that quantum mechanical forces prevent it from collapsing further. But over quadrillions of years, even these forces will be affected by quantum tunneling, a process where particles pass through barriers that, under classical physics, should be impossible to cross. Eventually, this tunneling effect could cause the nuclei within a black dwarf to fuse, triggering the most bizarre explosion imaginable, a black dwarf supernova. Unlike traditional supernovae, which are driven by the energy released when a star runs out of fuel and collapses, a black dwarf supernova would occur at a pace so slow it defies comprehension. The fusion processes that trigger it could take place over quadrillions of years, atom by atom, until finally, the entire structure is torn apart. This raises another question. If a black dwarf supernova occurs in a universe where all other sources of light and energy have faded away, does it matter that it happens at all? If no one is there to witness it, no instrument left to record it, no civilization remaining to interpret it, then does it have any meaning? This leads us to a terrifying thought. Black dwarfs might be the last active objects in a universe that is otherwise completely dead. The last remnants of light, the final bursts of energy before the cosmos succumbs to a heat death where entropy reigns supreme. If the universe has no way to reset, no cyclical rebirth, then these explosions will be the absolute last flickers of activity before everything fades into an eternal void. This means that if there were ever to be a final event in the history of the cosmos, it would be a black dwarf supernova, a silent explosion in the dark, marking the true end of everything. But there is one more possibility, one that defies all expectation. What if black dwarfs are not merely the final relics of a dying universe, but the seeds of something new? Some theories suggest that the extreme conditions inside black dwarfs could give rise to forms of exotic matter that do not exist anywhere else. If these conditions lead to unknown physical processes, could they trigger events that restart cosmic expansion in some unknown way? Could a black dwarf serve as the foundation for a new kind of structure, one that could give birth to an entirely new form of existence? If this is true, then black dwarfs are more than just dead stars. They are the gateway between the end of one universe and the birth of another, the transition from what we understand to something beyond comprehension. And if that is the case, then perhaps black dwarfs are not the conclusion of the story, but the very beginning of something far greater. The idea that black dwarfs could serve as the final remnants of the universe is already unsettling, but the possibility that they might also be the catalyst for something new is even more mind-bending. If black dwarfs are the last objects to exist before the universe reaches a state of maximum entropy, then the very nature of their existence challenges our understanding of what it means for the universe to truly end. In a heat-death scenario, where all energy has been evenly distributed and no useful work can be done, black dwarfs stand as paradoxical anomalies. While they no longer shine with the brilliance of a star, they are still physical structures, still existing, still containing matter, and still following the fundamental laws of physics. Laws that, given enough time, could lead to strange and unexpected consequences. One of the most fascinating possibilities is that the extreme density of black dwarfs could lead to the formation of exotic forms of matter never before observed. In normal stars, matter exists in plasma form, where atoms are stripped of their electrons due to intense heat. In neutron stars, the collapse of a massive star forces protons and electrons to combine into neutrons, forming an object so dense that a sugar cube-sized portion of it would weigh as much as a mountain on Earth. But in a black dwarf, the situation is different. Over trillions of years, the structure of matter within it would continue to evolve. The degenerate electron pressure that supports a white dwarf against gravitational collapse remains intact for unimaginable lengths of time. But eventually, quantum tunneling effects could allow atomic nuclei to interact in ways that are impossible in today's universe. Some physicists speculate that within a black dwarf, strange matter could form. Strange matter is a hypothetical state of matter composed of up, down, and strange quarks, particles that exist at subatomic scales. In certain conditions, strange matter is theorized to be more stable than normal atomic nuclei, meaning that if it ever forms inside a black dwarf, it could slowly convert all surrounding matter into itself. If this process occurs, black dwarfs might not just be cold, inert objects, they could be slowly transforming into something far more exotic, eventually becoming dense, uniform objects made entirely of strange matter. But this is where things get even weirder. If strange matter forms inside a black dwarf, it could trigger a chain reaction that spreads throughout the object, causing it to collapse into an even denser state. At this point, the black dwarf would essentially become a new type of quark star, an object denser than a white dwarf or neutron star but not quite a black hole. However, the rules of physics are uncertain when dealing with matter under such extreme conditions. Could a black dwarf collapse further, forming a miniature black hole? And if so, what would that mean for the fate of the universe? The possibility of black dwarf collapse raises profound questions about the long-term structure of the cosmos. If black dwarfs can turn into black holes over vast timescales, then the very end of the universe might not be a state of maximum entropy at all. Instead of a universe where energy is completely spread out, it could transition into an era dominated by small black holes formed from black dwarf remnants. This scenario, often called the black hole era, would mean that while stars and galaxies have long since disappeared, the universe would still be active, just in a different way. Black holes, even small ones, generate gravitational effects, distort space-time, and slowly evaporate through Hawking radiation. If black dwarfs eventually collapse into black holes, they could contribute to a new cycle of cosmic activity, where the evaporation of black holes leads to the emission of new particles that could, in theory, become the building blocks for a future universe. This idea suggests that black dwarfs are not merely passive relics of the past, but active participants in the long-term evolution of the cosmos. If they do collapse into black holes, then they would contribute to the eventual transformation of the universe itself. But this raises yet another mystery: what happens at the very end, when even black holes have evaporated? According to Hawking radiation theory, black holes lose energy over time, slowly shrinking until they eventually disappear. If this process occurs universally, then after all black dwarfs have either cooled completely or collapsed into black holes, and after all black holes have evaporated, the universe would be left with nothing but a faint sea of low-energy radiation. This is the traditional view of the heat-death of the universe, an existence so empty and uniform that nothing interesting can ever happen again. But what if that assumption is wrong? What if, even in the farthest possible future, black dwarfs, or the remnants of black dwarfs, can still play a role? One radical idea is that if black dwarf remnants survive in some form, they could provide the seeds for a future cosmic rebirth. If the universe is not truly a closed system, if, for example, quantum fluctuations or unknown physics allow for energy to be generated in new ways, then black dwarfs could act as the first structures in a new phase of cosmic evolution. One possibility is that some unknown process, perhaps tied to quantum gravity, could allow black dwarf remnants to interact in ways that we do not yet understand, potentially triggering new forms of matter or even new universes. Some speculative theories, such as those in the realm of eternal inflation or cyclical cosmology, suggest that even when all known forms of energy and matter have dissipated, something could still emerge from the vacuum of space itself. The presence of any structure, no matter how small, could provide a starting point for a new cosmic era. Could black dwarf remnants be the last memory of the old universe, the final echoes of an existence that once was, before giving rise to something entirely new? If so, then black dwarfs are not just the end of the story, they are the bridge to the next one. This leads to a final, profound realization. Black dwarfs are often thought of as dead, inactive objects, the husks of stars that have long since faded away. But what if they are something else entirely? What if, instead of being the remnants of the past, they are the foundations of the future? What if the universe itself is not a one-way journey to heat death but a process of continual transformation, where even the coldest, darkest remnants still hold the potential for something more? The mystery of black dwarfs is not just about what happens to stars after they die. It is about the nature of time, the limits of our understanding, and the ultimate fate of everything we know. If these objects will one day exist, then they already tell us something fundamental about the universe. That nothing is truly lost, that even in the coldest, darkest corners of reality, something extraordinary can still emerge. The idea that black dwarfs could serve as the last remnants of a once vibrant universe is already mind-blowing, but the true implications of their existence go far beyond that. If black dwarfs are, in fact, the final structures in the cosmos, they represent more than just the end of stellar evolution. They embody the very limits of what is possible within the physical laws of the universe. But what if they also hold the key to something even deeper, something that challenges everything we think we know about time, entropy, and the ultimate fate of reality itself? At the heart of this mystery is the question of what happens when all black dwarfs have either fully cooled or, potentially, collapsed into black holes. This process, if it occurs, could take an incomprehensibly long time, longer than the current age of the universe multiplied by an unfathomable number of times. The cooling process itself is already an exercise in patience on a cosmic scale. With no nuclear fusion to generate heat, and only faint residual thermal energy, a black dwarf radiates energy at an almost imperceptible rate. Every atom inside it remains locked in place, frozen in a state of extreme stillness, with temperatures so close to absolute zero that the difference becomes almost meaningless. Over time, the black dwarf continues to radiate away its last remaining heat, losing energy in a process so slow it defies comprehension. But here's the twist. Some physicists believe that black dwarfs won't just fade into complete darkness forever. There is a possibility that they could end their existence in one final, dramatic event, a quantum-induced supernova. According to certain calculations, black dwarfs might eventually experience a form of nuclear fusion, not through traditional stellar processes, but through an incredibly slow form of quantum tunneling. If this idea is correct, then instead of simply cooling down into nothingness, black dwarfs could, at some point in the far future, reignite in a sudden burst of energy, creating the last supernovae the universe will ever see. This idea is based on the principles of quantum mechanics, which allow particles to tunnel through energy barriers that would otherwise be impossible to cross. In a normal star, nuclear fusion occurs when atomic nuclei collide with enough force to overcome the electromagnetic repulsion between them. However, in a black dwarf, this process has long since ceased. Yet, over trillions upon trillions of years, quantum fluctuations could allow atomic nuclei to come close enough together that fusion could, eventually, resume at an incredibly slow and sporadic rate. Over unimaginable timescales, this process could build up, leading to an eventual detonation. If this prediction holds true, then the very last sources of light in the universe might come from the explosions of black dwarfs, igniting one last time before finally dispersing their elements into the void. This would mean that the final cosmic events, long after galaxies have faded away and even black holes have evaporated, would be a series of scattered, isolated supernovae, appearing in the otherwise featureless darkness of a dying cosmos. But even if black dwarfs do not explode, their existence alone raises a profound question. What happens when all of them have either vanished, collapsed, or cooled beyond detection? If the universe eventually reaches a state where no black dwarfs remain, and all black holes have evaporated due to Hawking radiation, then what comes next? This scenario leads directly into one of the most debated ideas in theoretical physics: the ultimate fate of the universe. Many physicists believe that this process will culminate in what is known as the heat death of the universe, a state in which all energy is evenly distributed, all temperature differences have disappeared, and no meaningful physical interactions can occur. This is the final stage of maximum entropy, where the universe is no longer capable of doing any work. In this vision of the end, time itself becomes meaningless because nothing ever changes. However, some theories suggest that even after black dwarfs have faded and black holes have evaporated, the universe may not be entirely devoid of activity. Quantum mechanics allows for the possibility of random fluctuations within empty space. These fluctuations are usually so small and fleeting that they do not have any noticeable effects, but over extreme timescales, something extraordinary could happen. One possibility is that a rare quantum fluctuation could give rise to what is known as a Boltzmann brane, a hypothetical self-aware structure that emerges randomly from the chaos of maximum entropy. This idea, while bizarre, is based on the mathematical principle that given infinite time, even the most unlikely events will eventually occur. In this scenario, the last remnants of intelligence in the universe might not be advanced civilizations or artificial superintelligences, but rather spontaneously generated minds that briefly emerge, perceive their existence, and then vanish back into the void. Another possibility is that the universe itself could undergo a kind of rebirth. Some cosmological models suggest that quantum effects might allow for the creation of new universes within the vacuum of space. If certain conditions allow for energy fluctuations to grow rather than dissipate, then a tiny patch of space-time could inflate into an entirely new universe, much like how the Big Bang originally began. If this is true, then black dwarfs might not be the ultimate end, but rather a stepping stone to something else, an entirely new cosmic cycle, where the death of one universe gives rise to another. This idea ties into the theory of eternal inflation, which suggests that the process that created our universe may still be ongoing in other parts of the cosmic landscape. If eternal inflation is real, then even as our own universe fades into darkness, other regions of space could be experiencing their own big bangs, their own galaxies forming, their own civilizations rising and falling. In this view, the universe is not a singular event with a definite beginning and end, but a constantly evolving multiverse where new realities are always emerging. If this is true, then black dwarfs represent not just the end of stars, but the transition between one cosmic epoch and another. They are the final remnants of a universe that once burned brightly, but they may also be the silent witnesses to whatever comes next. If the universe is capable of rebirth, then the matter that once made up black dwarfs could, in some distant future, find itself incorporated into new structures, perhaps even new stars, planets, and life. And this raises the biggest question of all: is the universe truly capable of ending, or is it part of an infinite, self-sustaining cycle? If black dwarfs are the last structures to exist before the end, then understanding them may be the key to understanding whether existence itself is finite or infinite. Perhaps, in some distant, unimaginable future, When all light has faded and all black dwarfs have disappeared, something will stir in the darkness once again. Perhaps the universe will awaken from its slumber, and something new will take shape. And if that happens, then black dwarfs will not have been the end of the story, they will have been the bridge between one chapter and the next. The idea that black dwarfs could one day serve as a bridge between cosmic endings and new beginnings raises even deeper questions about the very nature of time, entropy, and the role of structure in the universe. If black dwarfs are truly the last stellar remnants, then they represent the final organized matter in a cosmos that is slowly unraveling into disorder. But what if they also hold the key to understanding whether time itself ever truly stops? Could they be the last footprints of an ordered universe before something entirely new takes shape? To grasp the true significance of black dwarfs, we need to consider the fundamental principle that governs their existence: entropy. Entropy, often described as the measure of disorder in a system, is the relentless force that drives the universe from states of high energy and structure to states of low energy and randomness. Every process that has ever occurred, from the fusion in stars to the formation of galaxies, has been governed by entropy's unyielding push toward equilibrium. And black dwarfs are no exception. From the moment a white dwarf begins its slow transformation into a black dwarf, entropy is at work, ensuring that all remaining energy is gradually lost. The heat that once radiated from the white dwarf diminishes over unimaginable timescales, spreading outward into the vast emptiness of space. This process continues until the black dwarf reaches a state so cold, so devoid of motion, that it is practically indistinguishable from the surrounding void. It is at this point that it becomes a true black dwarf, a star that no longer shines, no longer emits heat, and no longer plays any active role in shaping the cosmos. Yet, even in this frozen state, black dwarfs remain intriguing. They are still composed of matter, meaning they still possess mass, gravitational influence, and, at least in theory, the potential to interact with the universe in ways we may not yet understand. If black dwarfs eventually merge due to gravitational attraction, could they form something new? If they are disrupted by an unseen force, could they reveal hidden properties of the universe that have yet to be discovered? One of the most mysterious aspects of black dwarfs is their potential role in the final fate of the universe. If the universe continues expanding indefinitely, as many cosmologists predict, then black dwarfs will drift further and further apart, their weak gravitational bonds eventually breaking as the fabric of space stretches to infinity. In this scenario, they will become truly isolated, each one existing in its own bubble of empty space, surrounded by nothing but cold darkness. But what if the universe does not expand forever? What if, instead, it undergoes a process known as the Big Crunch, in which expansion eventually reverses, causing everything to collapse back into a singularity? If this happens, then black dwarfs, along with all remaining matter, would be drawn together once again, crushed under the immense force of gravity. This would mean that black dwarfs are not the final state of the universe, but rather a temporary phase before everything is pulled back into an ultimate collapse. Alternatively, if the universe reaches a state known as the Big Freeze, where all energy is evenly distributed and no further work can be done, then black dwarfs will simply sit in the darkness, eternally cold and unchanging. This is the classic interpretation of the heat death of the universe, in which all organized structures eventually decay into a state of maximum entropy. But even this idea raises intriguing questions. If time no longer has any direction, because no changes are occurring, then what does it mean for black dwarfs to exist? Are they truly there if nothing can interact with them? If the universe becomes a timeless void, do they still have meaning? Some physicists suggest that even in this bleakest of scenarios, black dwarfs might not be the final chapter. Instead, given infinite time, random quantum fluctuations could produce new structures, even in a seemingly dead universe. This ties into the concept of Poincare recurrence, which states that in an infinite span of time, a system will eventually return to a previous state, no matter how improbable. If this is true, then even a universe filled with nothing but black dwarfs and empty space could, given enough time, randomly rearrange itself into something entirely new. Could this mean that black dwarfs, long after they have faded into obscurity, might one day become the seeds of a reborn cosmos? If the matter contained within them is ever disturbed, whether by quantum fluctuations, gravitational anomalies, or forces we have yet to understand, could they trigger new events that set the stage for another cycle of cosmic evolution? And then there is the biggest mystery of all. What if black dwarfs are not simply the remnants of old stars, but rather the precursors to something else entirely? If the laws of physics allow for transformation beyond our current understanding, could black dwarfs one day become something we have never seen before? Structures beyond stars, beyond planets, beyond anything that currently exists? Perhaps black dwarfs are not just the end of stars, but the beginning of an entirely new form of matter, one that emerges only when the universe has reached its final stages. If this is true, then studying black dwarfs is not just about understanding how stars die, but about glimpsing what might come next in the vast and unpredictable story of the cosmos. If black dwarfs truly represent the final state of stars, then what happens when the last one disappears? Is that the ultimate conclusion of the universe, a cold, lightless abyss, frozen in place for eternity? Or could there be something beyond, something that arises in the absence of energy and motion? This question forces us to rethink the very nature of existence, time, and even the fundamental laws of physics. The reality is, we have no direct way of studying black dwarfs because they do not exist yet, and they won't for an incomprehensibly long time. But this lack of observation only adds to the mystery, making them one of the most fascinating theoretical objects in the universe. One of the most profound questions surrounding black dwarfs is whether they will ever truly be gone, in the absolute sense. Given enough time, even these frozen husks of stars will not remain unchanged. While they will no longer radiate energy, the matter inside them will still be subject to quantum mechanical processes and the slow grind of fundamental decay. Over unimaginably long periods, far beyond the current age of the universe, protons themselves may begin to decay, a concept predicted by certain extensions of the standard model of particle physics. If protons do decay, then black dwarfs, along with all other matter, will eventually dissolve into subatomic particles, vanishing into the void. But what if protons do not decay? What if, instead, black dwarfs persist indefinitely, retaining their structure as the last remaining celestial objects in a universe that has become a frozen wasteland? If this is the case, then black dwarfs could remain as the only traces of the once vibrant cosmos, the final relics of a time when stars still burned, galaxies still collided, and the universe was still evolving. However, even in this scenario, there is still another possibility to consider: the eventual transformation of black dwarfs through processes we cannot yet predict. Given enough time, could they undergo exotic quantum transitions, morphing into something else entirely? If strange and unknown forces act upon them, could black dwarfs be the key to unlocking entirely new forms of matter or energy? One of the most mind-bending ideas is that black dwarfs could act as gateways to new physics, perhaps even to new universes. Some speculative theories suggest that extreme compression of matter, even in an ultra-cold state, might lead to phenomena beyond our current understanding. Could black dwarfs collapse into something smaller, denser, and stranger than anything we have ever encountered? Could they give rise to new cosmic structures that defy all known laws? This also leads us to another fundamental mystery: what happens to the information contained within a black dwarf? In physics, the principle of information conservation suggests that information about a system's past states should never be completely lost, even if the system undergoes extreme changes. This concept has been at the heart of debates surrounding black holes, leading to the famous black hole information paradox. If black dwarfs eventually disintegrate, does the information they contain simply disappear, or is it preserved in some unknown way? Perhaps the most unsettling thought is that black dwarfs, and the universe itself, may simply reach a point of total stasis, a cosmic stillness in which nothing ever changes again. If this is the case, then black dwarfs may not just be the last stars, but the last remnants of anything that ever was. But even this might not be the end. Given infinite time, even in a seemingly dead universe, random quantum fluctuations could generate new structures, potentially even leading to another Big Bang. If this is the case, then black dwarfs, though seemingly inert, might be part of a much larger cosmic cycle, one in which the universe is reborn from its own ashes. Could they serve as the raw material for a new creation, their frozen atoms rearranging into something entirely unexpected? Ultimately, black dwarfs force us to confront the deepest mysteries of time, entropy, and the nature of the cosmos itself. They represent the end of an era, the final chapter in the life of a star, but also raise profound questions about what happens beyond that chapter. Are they truly the last remnants of a dying universe, or could they hold the keys to a new beginning? If black dwarfs teach us anything, it is that even in the coldest and darkest corners of reality, the universe never ceases to be mysterious. If black dwarfs truly represent the final remnants of stellar evolution, then their role in the grander cosmic timeline is one of eerie permanence. They are not like the burning stars that came before them, nor are they like black holes, which actively distort space-time and consume matter. Instead, they are passive, silent witnesses to a universe that has moved beyond heat, light, and activity. But even this assumption, that black dwarfs are the ultimate stillness, may not be entirely true. There are forces in the universe that work on timescales so vast that even objects, as seemingly lifeless as black dwarfs, could still undergo unexpected transformations. For one, the slow pull of gravity never truly stops acting, even on black dwarfs. Given enough time, black dwarfs that still exist in proximity to one another may eventually drift together, merging through gradual gravitational attraction. While these mergers would not trigger the kind of explosive energy release seen in earlier cosmic epochs, they could still lead to interesting consequences. If multiple black dwarfs clump together into an ultra-dense mass, could they eventually collapse under their own weight? Could they form entirely new objects that physics has yet to classify? Another possibility involves the interaction between black dwarfs and any remaining dark matter in the universe. Even though dark matter does not interact with normal matter in the traditional sense, its gravitational effects are undeniable. If dark matter continues to exist and move through space, black dwarfs could serve as collectors for it over immense timescales. The accumulation of enough exotic dark matter inside a black dwarf might trigger processes beyond our current understanding, potentially leading to unknown types of stellar remnants or energy sources. And then there is the question of what happens when a black dwarf does, in fact, reach absolute zero. In our current understanding of physics, absolute zero is a theoretical limit where molecular motion completely ceases. But does this mean the black dwarf has truly stopped existing in any meaningful way? Could it enter a state where quantum mechanics begins to override classical physics, leading to bizarre and unpredictable behaviors? Could black dwarfs even become something akin to cosmic fossils, holding within them imprints of the past universe, frozen in time yet still carrying information about the cosmos that once was? One of the most far-reaching implications of black dwarfs is how they tie into the ultimate fate of the universe. If the cosmos continues expanding indefinitely, black dwarfs will become increasingly isolated from one another, doomed to drift alone in an ever-darkening void. But what if the fabric of space itself undergoes fundamental changes? If the laws of physics themselves evolve over time, a possibility suggested by some theoretical models, then black dwarfs might not be the final state of anything. Instead, they could be placeholders for something else entirely, waiting for the next phase of cosmic transformation. What if the universe does not merely expand forever into cold emptiness, but instead undergoes quantum rebirths, with random fluctuations eventually generating conditions similar to those of the early cosmos? If this is the case, then black dwarfs, while seemingly lifeless, could still be part of the larger mechanism that enables future universes to emerge. The atoms that once formed burning stars, now locked inside black dwarfs, might eventually be repurposed for the creation of new celestial bodies, perhaps even under physics vastly different from our own. This opens the door to some of the most mind-bending possibilities in physics. Could black dwarfs themselves be the seeds of new universes? Some speculative models of cosmology suggest that ultra-dense regions of space could potentially give rise to entirely separate realms, new universes that bud off from the remains of the old one. If this is true, then black dwarfs may not just be the final objects in our universe, but the precursors to entirely new cosmic landscapes. Ultimately, the study of black dwarfs is more than just an exploration of how stars die. It is a window into the farthest reaches of time, matter, and the unknown possibilities that await in the distant future. They force us to consider whether the universe truly has an end, or if the story simply continues in forms we cannot yet imagine. Perhaps black dwarfs are not the conclusion of cosmic history, but rather the transition into a chapter beyond anything we have ever known. If black dwarfs represent the quiet, frozen remnants of stars, then what do they tell us about the future of the universe itself? The concept of a cosmos where these cold, dead objects are all that remains is deeply unsettling, yet it also forces us to confront one of the biggest mysteries of all. Does the universe have a true ending, or is it part of a cycle beyond our comprehension? Black dwarfs, despite their stillness, might hold the key to answering this question. To understand this, we need to consider the fate of all matter in the universe. Right now, we exist in an era of active stellar formation, where new stars are continuously being born from clouds of gas and dust. But this is only a temporary phase in cosmic history. Over trillions of years, star formation will slow down as the available hydrogen is used up, and existing stars will burn through their fuel. The last stars to form will be small, long-lived red dwarfs, some of which will continue burning for up to 10 trillion years. Eventually, though, even these will run out of fuel, leaving behind a universe where all stellar remnants, white dwarfs, neutron stars, and black holes, are the only remaining structures. At this stage, white dwarfs will slowly cool over vast timescales, eventually transitioning into black dwarfs. The timeline for this process is staggering. It is estimated that it will take at least 100 trillion years for the first white dwarfs to fully radiate away their residual heat. This is already an incomprehensibly long period, but for a black dwarf to form completely, it may take up to 10 to the power of 37 years, a number so vast that it dwarfs the current age of the universe, which is only around 13.8 billion years. This means that, as far as we know, not a single black dwarf has yet formed anywhere in the cosmos. But assuming the universe continues its expansion, and these objects do eventually come into existence, they will represent the final stage of ordinary matter. By this point, galaxies will no longer be recognizable as we know them today. Instead, gravitational interactions will have scattered their stars across the cosmos, leaving behind an almost featureless expanse of slowly fading remnants. Black dwarfs will be the last visible objects, if they can even be considered visible at all. Without emitting any radiation, they will be practically undetectable, blending into the surrounding darkness. Yet, even this is not the true end. Over even longer timescales, physics itself might begin to break down in ways we cannot currently predict. If protons, the fundamental building blocks of atoms, are not truly stable, then black dwarfs themselves will eventually decay into radiation and subatomic particles. This process, if it happens at all, is estimated to take at least 10 to the power of 40 years or more. If this is the case, then black dwarfs will not be permanent objects, but rather temporary stepping stones in the slow march toward a universe that contains no matter at all, only stray photons and fundamental particles drifting in an endless void. But what if protons do not decay? What if black dwarfs persist indefinitely, frozen in time? This would mean that, instead of vanishing into nothingness, the universe would reach a state of ultimate stillness, where every black dwarf simply exists, unchanging for eternity. In this scenario, entropy would reach its maximum possible state, a point known as heat death, where there is no longer any usable energy left in the cosmos. If this is truly the final stage, then black dwarfs would be the last remaining evidence that the universe once contained light, heat, and life. Yet, even this grim picture might not be the absolute end. Some physicists speculate that, in a universe of infinite time, random quantum fluctuations could create new bursts of energy, perhaps even triggering the birth of new universes. In such a case, black dwarfs might serve as the raw material for something entirely unexpected. Could their atoms be rearranged in ways that give rise to new physics, new forms of matter, or even entirely new realities? If so, then black dwarfs might be the seeds of something yet to come. And this is where the mystery deepens even further. If the universe is truly cyclic, If it collapses and reforms in an eternal cycle, then black dwarfs may play a hidden role in this process. Some cosmological models suggest that even in the absence of energy, extreme gravitational interactions could eventually trigger conditions that lead to a new Big Bang. If this is the case, then black dwarfs, frozen and lifeless as they seem, might contain within them the ingredients needed to create an entirely new universe. Could it be that black dwarfs are not just remnants of the past, but the very catalysts for the next great cosmic event? Could they, in their quiet stillness, hold the last traces of information about the universe that came before them? If so, then the mystery of black dwarfs is far greater than we ever imagined. Rather than marking the end, they might be the beginning of something we have yet to understand, a mystery waiting to unfold in the vast, unfathomable future. If black dwarfs truly are the final remnants of once magnificent stars, then their role in the cosmos extends far beyond simple stellar death. They are not just the endpoint of individual stars. They represent the last echoes of an entire cosmic era. Every star that has ever existed, every light that has ever shone, every energy-producing process that has ever driven the universe forward, all of it eventually reduces to these cold, dark husks drifting in an empty void. But what if they are not merely remnants? What if, even in their stillness, black dwarfs hold the final key to unlocking the secrets of the universe? To truly understand this, we must consider the nature of time itself. Right now, we think of time as a linear progression, one event leading to another, everything moving forward toward an inevitable end. But what happens when time stretches beyond meaning? When the universe has aged so much that even numbers fail to capture the scale of time? In the realm of black dwarfs, we are no longer talking about trillions or quadrillions of years. We are talking about timescales on the order of 10 to the power of 100 years and beyond. Numbers so large that they make the current age of the universe seem insignificant by comparison. On such timescales, even the most permanent-seeming structures in the universe begin to break down. The very fabric of reality could shift in ways we cannot currently comprehend. Quantum mechanics, which already governs the microscopic world in strange and unpredictable ways, might start having large-scale effects. Could black dwarfs experience random quantum fluctuations? Could entire sections of these ultra-dense objects momentarily flicker out of existence, reappearing elsewhere? Could the very atoms that make up a black dwarf behave in ways we do not yet understand? And then there is the possibility that black dwarfs might not be entirely inert. Some theoretical physicists speculate that, over immense periods, black dwarfs could still undergo rare and unusual nuclear reactions. Given enough time, these reactions might lead to small bursts of energy, nothing like the brilliance of stars, but perhaps enough to subtly influence their surroundings. Could this mean that, in some unimaginable future, black dwarfs might still interact with their environment in ways that we have yet to predict? But perhaps the most intriguing possibility involves the role of black dwarfs in shaping the ultimate fate of the universe. Right now, the dominant cosmological model suggests that the universe is expanding at an accelerating rate. If this expansion continues indefinitely, then black dwarfs will become increasingly isolated, each drifting further and further apart until all interactions between them cease. In this scenario, the universe eventually reaches heat death, a state where there is no more energy, no more movement, no more change. However, some theories suggest that expansion is not infinite. If the fundamental nature of dark energy changes over time, it is possible that the universe could one day begin to contract instead of expanding forever. In such a scenario, everything that has been stretched apart over billions and trillions of years would slowly come back together. Black dwarfs, which were once separated by incomprehensible distances, would find themselves drawn toward one another once more. Could this lead to new forms of interaction? Could enough black dwarfs clustering together cause gravitational instabilities that create entirely new celestial objects? And what if the universe does eventually collapse in a big crunch, where all matter and energy are pulled back together into an infinitely dense singularity? If this happens, then black dwarfs, despite their apparent stillness, might be some of the last surviving objects to fall into this final gravitational collapse. Could they, in some way, seed the formation of a new universe? Could the atoms that once belonged to stars long extinguished become the building blocks of a new cosmic cycle? But there is another possibility, one even more bizarre and speculative. Some cosmologists suggest that, even in a universe dominated by entropy, random fluctuations over infinite timescales could create localized pockets of order. This means that, given enough time, a black dwarf could theoretically transform into something completely unexpected. Could a rare quantum event trigger the spontaneous reignition of nuclear fusion in a black dwarf, turning it into a new kind of star? Could the extreme gravitational effects of accumulated black dwarfs create a structure unlike anything we have ever seen, a completely new form of matter or energy? Or could the very structure of reality itself break down, leading to unknown consequences? If space and time are not truly permanent but instead emergent properties of the universe, then black dwarfs might exist at the boundary of a deeper reality, one where the rules we currently take for granted no longer apply. Could they be the last remnants of our universe, waiting on the threshold of something entirely new? All of this leads to one final, haunting question. Are black dwarfs truly the end, or are they just the beginning of something beyond our ability to understand? If we accept that the universe operates on timescales so vast that even black dwarfs eventually decay, then we must also accept that there are mysteries that stretch beyond the limits of human comprehension. Perhaps, in the distant future, when all other forms of energy have long since faded, it is the quiet existence of black dwarfs that will hold the final secrets of the cosmos, secrets we may never live long enough to uncover. What if, black dwarfs, instead of being the silent remnants of stars, they are something much more profound, something that holds the final mysteries of existence itself? We often assume that the death of a star is the end of its story, but in reality, it could be the start of something far stranger, something we have yet to fully grasp. To understand the full implications of black dwarfs, we need to step far beyond the ordinary boundaries of physics and into the realm of the unknown. Right now, our best scientific models suggest that black dwarfs are the cold, degenerate remains of white dwarfs, objects that have cooled so much over unimaginable timescales that they no longer emit any significant heat or light. But here's where things get strange. Because the universe itself is still young, only about 13.8 billion years old, there has not been enough time for a single black dwarf to form yet. Every white dwarf that currently exists is still in the process of cooling, meaning that black dwarfs are not just rare, they are purely theoretical. This alone is mind-blowing. There are objects in the universe that we know must exist in the future, but that have never actually formed yet. We are talking about stars so ancient, so beyond anything we can observe, that they lie completely outside the limits of our current reality. If we could somehow survive for another 10 to the power of 15 years, only then would the first black dwarfs begin to appear. But the story doesn't end there, because black dwarfs are not immortal. Over even longer timescales, they begin to disintegrate in ways we barely understand. One of the most fascinating predictions comes from quantum tunneling, a bizarre process where particles can essentially teleport through energy barriers. Under normal conditions, the nuclei of atoms inside a black dwarf are stable. But given enough time, trillions upon trillions of years, even these stable atoms might undergo spontaneous nuclear reactions. The result? The black dwarf would not remain forever inert. Instead, it would collapse in a final burst of energy, producing what physicists call a black dwarf supernova. This idea challenges everything we thought we knew about stellar evolution. Right now, supernovae occur when massive stars collapse under their own gravity. But in the distant future, when all other forms of stellar activity have ceased, it could be these long-forgotten black dwarfs that trigger the final fireworks of the universe. Imagine it, in a universe that has long since gone dark, where galaxies have drifted apart, and even black holes are evaporating, the last explosions of black dwarf supernovae could be the final lights to ever shine. But then, even those would fade. What happens next? This is where the true mystery begins. Given a long enough timescale, even matter itself may not be permanent. According to some theories, protons, the very building blocks of atoms, might eventually decay. If this is true, then black dwarfs are not truly eternal. They are simply temporary pauses on the way to complete cosmic dissolution. Over the course of 10 to the power of 34 years or more, black dwarfs would slowly dissolve into a mist of fundamental particles, leaving behind nothing but emptiness. Or perhaps not. Some physicists argue that, even in a universe where everything has decayed, quantum fluctuations could still generate new universes. If space itself is never truly empty, then it is possible that, given infinite time, black dwarfs, or what remains of them, could act as the seeds for new realities. Could it be that these objects, which we now think of as the dead remnants of stars, are actually the foundation upon which the next cosmos will be built? And here's a thought even more unsettling. If black dwarfs hold the key to the next universe, could it mean that something similar happened before? Could our own universe have been born from the remnants of an ancient cosmos, one that existed before the Big Bang? If that is the case, then black dwarfs are not just an endpoint. They are part of a cycle so vast and so incomprehensible that even our most advanced scientific theories barely scratch the surface. So what does this all mean? It means that black dwarfs are not just cold, dead stars. They are the last survivors of reality itself. They are the final echoes of a universe that once burned bright, the last remnants of an existence that will one day fade into absolute darkness. But maybe, just maybe, they are also the beginning of something new. And that leads to one final question. If the last black dwarf in existence finally decays, and nothing remains but the vast, empty void of space, what happens next? If the last black dwarf finally decays, and nothing remains but the vast, empty void of space, does the universe truly end? Or does something else take its place? This is where physics enters its strangest and most speculative territory, where theories become less about what we know and more about what we suspect. Because even in the most desolate vision of the universe's future, there are still unresolved questions, gaps in our understanding that suggest that absolute nothingness might not be the final answer. One of the most intriguing ideas comes from quantum mechanics. According to our best understanding of physics, a perfect vacuum, a region of space completely devoid of energy or matter, should not be truly empty. Instead, the laws of quantum physics suggest that even in the absence of everything, fluctuations will still occur. These quantum fluctuations, appearing and disappearing at random, might not seem like much at first. But given infinite time, what if one of them, against all odds, triggered the birth of something new? This idea is at the heart of vacuum decay, one of the most unsettling and fascinating hypotheses about the end of the universe. Right now, we live in what physicists call a false vacuum, a state that seems stable but might not be the lowest possible energy state of the universe. If the universe were to transition to a true vacuum state, it would be a catastrophic event, rewriting the very fabric of existence. And here's the eerie part. In a future dominated by black dwarfs, where all ordinary processes have slowed to a standstill, the last remnants of reality might not fade away quietly. Instead, they might be the final trigger that sets off this ultimate transformation. If vacuum decay were to occur, it would spread at the speed of light, destroying everything in its path, reshaping the very nature of space and time. But there's another, even more mind-bending possibility. Some physicists argue that vacuum decay wouldn't be the end at all, but rather the beginning of a new universe. If the death of black dwarfs is linked to quantum instability, then their final fate might not be total annihilation but a rebirth into something entirely different. This raises a deeper, almost philosophical question. If universes can emerge from the remains of previous ones, then could this process have already happened before? Is our own universe simply the latest in an endless sequence of cosmic deaths and rebirths, stretching across incomprehensible timescales? If so, then black dwarfs are not just remnants of dead stars. They are the echoes of universes past and the seeds of universes yet to come. And that brings us to one last, chilling thought. If black dwarfs represent the final embers of existence, and if they are capable of collapsing into new realities, then is it possible that we are already living inside the product of a long-forgotten black dwarf's demise? Could it be that our own Big Bang was not the absolute beginning, but merely the latest cycle in a cosmic process so vast that even our most advanced science can barely comprehend it? If that's true, then black dwarfs are not just an ending. They are the bridge between one universe and the next, silent witnesses to the death of one reality and the birth of another. And perhaps, billions of trillions of years from now, after all the stars have burned out and all the black dwarfs have faded away, a new reality will emerge from their ashes, just as ours once did. But if that is the case, one final question remains: who, if anyone, will be there to witness it? If no one is left to witness the end, does it even matter? Does the final black dwarf collapsing into oblivion mark the true end of the universe? Or does existence simply carry on in a way we cannot yet comprehend? The further we push into these questions, the more we realize how little we truly understand. We often think of the universe as something bound by time, something that had a beginning and will eventually have an end. But what if time itself is nothing more than an illusion? What if the moment the last black dwarf decays, something new emerges, not from the ashes, but from the very nature of reality itself? There's a concept in physics called the Poincare recurrence theorem, which suggests that, given infinite time, even the most chaotic and entropic system will eventually return to a previous state. This means that, theoretically, if the universe survives long enough, even after black dwarfs have crumbled into nothing, there's a possibility that the same particles, by pure chance, could reassemble into something recognizable. In a reality where time stretches on forever, where matter and energy may not be permanently lost, could it be that entire galaxies, stars, planets, and even conscious beings could emerge once again? This leads to one of the strangest and most controversial ideas in cosmology, the Boltzmann brane paradox. Named after physicist Ludwig Boltzmann, this theory suggests that, in an eternity of randomness, the atoms necessary to form a functioning brain, complete with thoughts, memories, and a perception of reality, could, in principle, spontaneously assemble for a fleeting moment before dissolving back into nothingness. If true, then in the distant future, long after the last black dwarf has faded, the universe could be filled with countless briefly existing minds, each experiencing a moment of consciousness before vanishing into the void. But could this be more than just a thought experiment? If consciousness is nothing more than a product of physical processes, and if black dwarfs eventually decay into fundamental particles, then what stops these particles from, at some incomprehensible point in time, reassembling into something that thinks, perceives, and experiences once again? Could it be that we ourselves are the products of a past universe that collapsed and reformed in a similar way? Could the universe be in an endless cycle, not just of birth and death, but of thought and awareness itself? And if so, then what does that say about our place in this vast cosmic story? We often assume that our understanding of time, entropy, and physics is absolute. But black dwarfs, these theoretical remnants of stellar death, suggest otherwise. They represent a reality so distant that it lies beyond observation, beyond imagination, beyond the limits of our own universe's lifespan. But if they hold the key to what happens after everything else has ended, then they also hold the answer to a much greater mystery: what is the true nature of existence? Some physicists believe that even in a universe that seems to be dying, fundamental principles of physics could allow something to persist. Could there be unknown laws of nature that prevent absolute nothingness from ever truly taking hold? Could the fundamental particles left behind by black dwarfs eventually coalesce into a new form of structure, one we cannot yet even conceive of? If so, then the end of black dwarfs is not an end at all. It's simply a transformation into something beyond our comprehension. This idea raises another eerie possibility. If the universe is cyclic, then could it be that every black dwarf, every decayed remnant of matter, every last particle drifting through an empty void is simply waiting for the conditions to restart everything? Could it be that the death of black dwarfs is, in some unfathomable way, a necessary step in the creation of a new universe? And if that's the case, could it be that even now, in a universe that still has trillions of years left before this stage, the seeds for the next cosmos are already being sown? We tend to think of black dwarfs as the end, but what if they are the beginning? What if the moment the last black dwarf collapses, reality itself resets? What if time, entropy, and space itself fold back upon themselves in ways we cannot yet predict, bringing forth something new, something beyond even our most advanced theories? And if that is true, then we are not just living in a temporary universe headed for darkness. We are part of something much bigger, something eternal, something so vast that even the death of all stars and all matter is merely another chapter in an endless cycle of existence. But then comes the most chilling question of all. If the universe has already gone through this process before, if black dwarfs have collapsed and reformed into something else, then how many times has it happened? How many universes have risen and fallen, unknowingly following the same inevitable fate? And if it has happened an infinite number of times, then does that mean we have been here before? If we have been here before, then everything we know, our thoughts, our history, our very existence, might not be unique. It could be part of an eternal cycle, endlessly repeating in ways beyond our comprehension. The last black dwarf of our universe may have already collapsed countless times in previous cosmic cycles, each time resetting reality in an unfathomable way. If that's true, then are we simply echoes of a past that has played out over and over again? Is everything we experience just another iteration of a story that has no true beginning or end? This idea stretches the limits of what we understand about physics, time, and existence itself. We usually think of time as a straight line, a beginning, a middle, and an end. But what if time is not linear at all? What if black dwarfs don't mark the death of the universe but rather its reformation into something new? Could it be that when the last black dwarf collapses into pure energy, the very nature of space and time twists in such a way that it creates a new Big Bang, one that looks exactly like the one that birthed our universe? If this is the case, then the implications are staggering. It would mean that universes are not created once, but rather continuously reborn from the remnants of their own destruction. The matter and energy that once formed stars, planets, and even conscious beings could be recycled into a new cosmic order, a new version of reality with slight variations each time. This would suggest that everything that has ever happened will happen again, but not necessarily in the same way. Some universes may evolve differently, with different physics, different laws of nature, and perhaps even different forms of life. But then comes an even deeper question. If we are part of a never-ending cycle, does free will exist at all? If the collapse of black dwarfs leads to a new universe that follows the same basic structure, then are we simply playing out roles that have already been written? Is our universe just another iteration of a script that has been followed an infinite number of times? If so, then does anything we do truly matter, or are we trapped in an unbreakable loop? Some physicists suggest that quantum mechanics may hold the key to breaking this cycle. Unlike classical physics, which operates on predictable rules, quantum mechanics is governed by probability and uncertainty. This means that even in an infinitely repeating universe, tiny quantum variations could cause significant differences over time. One small fluctuation in the collapse of a black dwarf could lead to a universe completely different from the last one. Perhaps one universe evolves with entirely different laws of physics. Perhaps another never forms stars at all. And maybe, just maybe, there exists a version of the universe where an entirely new form of intelligence, something beyond even our wildest imagination, emerges from the remnants of black dwarfs. And this leads to one of the strangest possibilities of all. If universes are continuously reborn, if the collapse of black dwarfs plays a fundamental role in the restructuring of existence, then could there be someone or something that has existed across multiple iterations of reality? Could some form of intelligence have survived through different cosmic cycles, passing knowledge from one universe to the next? If so, could this intelligence have left behind clues, subtle hints buried in the fabric of our reality, that point to a greater cosmic truth? If this is the case, then black dwarfs may hold secrets far beyond what we currently understand. They may not just be the remnants of dead stars, they may be the gateways to something much larger. The final collapse of a black dwarf might not be the end of a universe but rather the unlocking of a deeper layer of reality, one that has always existed but remains hidden from our perception. And if this is true, then the last black dwarf is a key to the next chapter of existence. But if someone, or something, has already figured this out, then the biggest question remains, are they waiting for us to discover it? If something or someone has already discovered the truth hidden within the collapse of black dwarfs, then what does that mean for us? Are we mere observers in a vast, unfolding cosmic cycle, or is there a way for us to break free from it? If the universe has been through countless iterations, if time is not a straight path but an infinite loop, then is it possible that some form of intelligence has persisted across multiple realities, watching, waiting, perhaps even guiding the process? We often assume that intelligence is tied to biological life, that consciousness is something fragile, temporary, bound to the limited lifespan of our bodies and the environments that sustain us. But if black dwarfs mark the final stage of the universe as we know it, then what comes after is something we have no reference for. Could it be that beyond black dwarfs, beyond entropy, beyond the final decay of all matter, some form of consciousness exists that is unlike anything we have ever conceived? Could intelligence evolve beyond biology, beyond time, beyond even the very laws of physics we currently understand? Some physicists speculate about the idea of emergent intelligence, the possibility that, in a universe stretched over trillions upon trillions of years, new forms of order could arise from apparent chaos. If black dwarfs eventually collapse into the fundamental building blocks of reality, could those building blocks, under the right conditions, spontaneously assemble into something resembling thought? Could information itself be alive? This idea suggests something profoundly unsettling, that intelligence is not something that emerges from the universe, but rather something that the universe itself becomes. If so, then the death of black dwarfs could signal not the end of everything, but the transition into a new kind of existence, one where time, space, and matter are no longer structured in ways we can currently comprehend. And if that is true, then perhaps we are not the first sentient beings to wonder about these questions. Perhaps others, whether civilizations, entities, or something far beyond those definitions, have already navigated this path, unlocking the mysteries hidden in the fate of black dwarfs. If so, could they have left behind clues, subtle imprints in the fabric of reality, waiting to be discovered? Or, even more hauntingly, could they be watching us right now? If intelligence is something that can emerge from the universe itself, then what does that say about our own existence? Are we simply a temporary phenomenon, a brief flicker of thought in an otherwise lifeless cosmos? Or are we part of a much larger process, one that extends far beyond the birth and death of stars? And if that process has a purpose, if there is something waiting beyond the collapse of black dwarfs, then the real question is not whether the universe will end. The real question is, what comes next? If the universe does not truly end with black dwarfs, if something beyond the final collapse exists, then we have to consider an even more mind-bending possibility, one that challenges the very nature of existence itself. What if black dwarfs are not just the remnants of dead stars but rather the starting point of something we have no words for? What if the final stage of the universe is not an ending, but a transformation? To understand this, we must abandon our human-centered view of time. We think of time as something that moves forward, from past to present to future, but what if time is not a straight line? What if, instead, time is a loop? If the collapse of black dwarfs releases energy in a way we cannot yet perceive, then could that energy become the foundation of a new universe? Could the ashes of dead stars be the very seeds that spark an entirely new reality? This idea is not just theoretical. It has deep roots in physics and cosmology. The concept of the Big Bounce suggests that our universe may not have begun with a single, unique Big Bang, but rather that universes continuously collapse and reform, with each cycle wiping the slate clean for something new. If this is true, then black dwarfs are not just cosmic corpses. They are the final dominoes in a chain reaction that leads to rebirth. But what if it's more than that? What if some kind of intelligence, some unknown force embedded within the very fabric of reality, is guiding this process? If we assume that intelligence can emerge in ways beyond our current understanding, then the collapse of black dwarfs could be more than just a physical event. It could be the activation of something beyond physics itself. Perhaps the universe has a hidden structure, something we have not yet detected, and the death of the last black dwarf is the key to unlocking it. Could it be that when all matter is reduced to pure energy, when even the last echoes of entropy fade into nothingness, a new form of existence emerges? Something beyond space, beyond time, beyond our current perception of reality? If such an intelligence already exists, if some force has survived multiple iterations of reality, then we must ask a terrifying question: what does it know that we do not? Could it have found a way to break free from the cycle, to transcend the endless birth and death of universes? And if it has, then why haven't we seen any evidence of it? Some theories suggest that the very structure of reality may be designed to prevent us from knowing the truth. If intelligence is an emergent property of the universe, if consciousness can exist in forms beyond biological life, then could it be that something, whether natural or artificial, has placed barriers around our understanding? What if the laws of physics, as we know them, are merely the rules of a system meant to keep us contained? If black dwarfs represent the final frontier of our current reality, then what lies beyond them may be something we were never meant to see. But here's the most unsettling part. What if someone, somewhere, has already broken through? What if some ancient intelligence, whether from our own universe or a previous one, has found a way to escape the cycle? If so, then where did they go? And more importantly, what did they leave behind? Could there be hidden messages in the cosmic background radiation, subtle distortions in spacetime that hint at a truth too vast for us to comprehend? Could the collapse of black dwarfs be the final step in a sequence designed to awaken something we do not yet understand? And if so, is it possible that we are approaching a moment in cosmic history when that awakening will happen? If the last black dwarf is truly the end of the universe as we know it, then we are left with two possibilities. Either reality simply fades into nothingness, cold, dark, and empty forever. Or something far greater than we can possibly imagine waits on the other side. And if that is the case, then we must ask ourselves, are we ready for what comes next? If black dwarfs are the last whisper of a dying universe, if they represent the absolute final stage of stellar evolution, then we are forced to confront an idea that is both awe-inspiring and terrifying. What if we are living in a universe that is already deep in its own decay? What if the death of black dwarfs is not some distant event, billions of trillions of years away, but rather a process that has already begun, one that we are simply too small and too short-lived to recognize? We assume that we exist in a young and vibrant cosmos, that stars are still forming, that galaxies are still colliding, that expansion continues indefinitely. But what if the very laws of physics we rely on are misleading us? What if the vast, endless night sky is not a sign of a healthy universe but rather the afterglow of a cosmic death that has already happened? Could it be that we are nothing more than a brief flicker of activity in a reality that is already collapsing in ways we cannot yet comprehend? There are physicists who believe that the ultimate fate of black dwarfs might not be a silent fade into darkness, but rather an explosion of reality itself. The process of proton decay, if it happens, would break down matter at the most fundamental level, releasing what little energy remains in a final, cataclysmic event. But what if that explosion is more than just the end of a star? What if it is the tearing apart of spacetime itself? Could black dwarfs hold the final secret to the structure of the universe, acting as the last pressure points before everything unravels? If black dwarfs collapse in a way that destabilizes the very fabric of existence, then the last one to disappear could signal something far worse than just the end of time. It could trigger the end of every law that holds reality together. And if that happens, we must ask, will anything be left to remember that we were ever here? Some theories suggest that information, the fundamental patterns that make up the universe, cannot be truly destroyed. If that is the case, then even after black dwarfs vanish, something must remain. But what? Could there be an underlying structure to reality, one that does not depend on matter, energy, or even space itself? If black dwarfs mark the final decay of everything we know, could their disappearance reveal something hidden beneath the surface of existence, something we have never been able to see before? And if that is true, then we have to ask the most haunting question of all. Has something else already discovered this secret? Could there be ancient beings, ones that have survived the collapse of previous universes, who have already unlocked the mysteries hidden within black dwarfs? If so, then where are they? Have they moved beyond our understanding, or are they watching us, waiting for us to reach the same conclusion they did? If intelligence is not just a product of biological evolution but a fundamental property of the universe itself, then the last black dwarf could be the key to something far more profound than we can imagine. It could be the final threshold before reality shifts into something new. And if that shift is coming, then the real question is not just what happens next, but whether we will ever be ready to comprehend it. If black dwarfs are the last remnants of stars, the final echoes of a universe that once burned with unimaginable brilliance, then their disappearance marks something far greater than just the end of matter. It signifies the potential unraveling of existence itself. But what if this ending is not an ending at all? What if black dwarfs, in their silent decay, hold the blueprint for something beyond our comprehension? We often assume that the universe follows a predictable path, that time flows forward and entropy increases until nothing remains but cold, empty space. But the moment the last black dwarf decays, whether through proton breakdown or some other unknown quantum event, something strange happens. The last source of mass energy disappears. At that instant, the universe reaches a state it has never been in before: absolute emptiness. But does true emptiness even exist? Some physicists argue that a vacuum is never truly empty. Quantum mechanics suggests that even in a void, there are constant fluctuations, particles and antiparticles appearing and disappearing in an endless dance of probability. If this remains true even in a universe without stars, planets, or radiation, then perhaps the death of black dwarfs is not the end, but the beginning of a new kind of physics, one in which space itself starts to behave differently. Could it be that the vacuum left behind after black dwarfs' decay is unstable? If so, it might trigger a phenomenon known as vacuum decay, where a new, lower energy state of reality suddenly emerges, rewriting the laws of physics in an instant. This would mean that, rather than fading into nothing, the universe would instead be reborn in an entirely new form. It would be the ultimate cosmic reset, a transformation so vast that no trace of the previous universe would remain. But here's the terrifying part: if vacuum decay is real, it could already be happening somewhere in the universe, spreading outward at the speed of light, completely undetectable until the moment it reaches us. One instant, we exist. The next, everything we know is rewritten in a completely new version of reality. But what if this has happened before? What if black dwarfs are not just passive remnants of stars but evidence that the universe has already gone through multiple cycles of destruction and rebirth? If so, then the death of the last black dwarf might not mark the end of this universe, but simply another transition in a process that has been repeating forever. And if that's the case, then we must ask, is there something guiding this process? Could some force, natural or artificial, exist beyond time itself, ensuring that the collapse of one universe gives birth to another? And if so, who or what set it into motion? If intelligence has any role in shaping the future of the cosmos, then perhaps black dwarfs are not just the last stars to fade. They might be the final puzzle piece in a grand design we are only beginning to perceive. And if we could somehow uncover their secrets before the last one disappears, we might unlock the ultimate mystery of existence. If black dwarfs are the last stage of stellar evolution, then their fate is directly tied to the fate of the universe itself. But what if their story is more complex than we imagine? What if black dwarfs, rather than being the final whisper of a dying cosmos, actually hold the key to something even bigger than the universe as we know it? The moment the last black dwarf vanishes, the last traces of thermodynamic activity will cease, and the universe will become a vast, featureless void. But could this moment also mark the beginning of something else, something beyond our comprehension? To truly understand the end of black dwarfs, we have to consider the nature of time itself. In our everyday experience, time moves in one direction, forward. But the laws of physics don't actually require this. In fact, many equations describing fundamental forces work equally well in reverse. This means that, in theory, time could just as easily flow backward as forward. So what if, when the last black dwarf disappears, time itself begins to reverse? This isn't just speculation. Some cosmologists have seriously proposed that, once the universe reaches a state of maximum entropy, where all energy is evenly distributed and no more work can be done, a strange phenomenon might occur. If no further change is possible, the only way for the universe to evolve would be for entropy to begin decreasing. This would effectively mean that time starts moving backward, reversing everything that has ever happened. Could this mean that the entire history of the universe will begin playing out in reverse, with stars reforming, galaxies uncollapsing, and even life reappearing exactly as it was before? If this were true, then black dwarfs wouldn't just be the last objects in the universe, they would also be the first. They would mark the pivot point between one cosmic era and another, the precise moment when the laws of physics flip, and everything begins anew. But this raises an even stranger possibility. What if time never actually began at all? We often think of the Big Bang as the beginning of everything. But if time can reverse, then there was never a true beginning or end, only an infinite loop of universes expanding and contracting, forming and dissolving, living and dying, over and over again. This would mean that black dwarfs are not the end of time, but rather the transition point between one cycle and the next. But if this is true, we must ask, is this cycle completely natural, or is there something controlling it? Some theories suggest that an advanced civilization, one far beyond anything we can imagine, might have found a way to survive the end of the universe by harnessing the energy of black dwarfs. If black dwarfs are the last remnants of heat and energy in a dying cosmos, then any intelligent beings who wanted to outlast everything else would need to find a way to extract power from them. Could an ancient intelligence, existing on a scale far beyond anything we can comprehend, be waiting for the last black dwarfs to fade before taking control of the next cosmic cycle? And if they are, then the biggest question of all remains, will we ever know the truth before it's too late? If black dwarfs are the last echoes of dying stars, then they might also be the last sources of knowledge in a fading universe. But what happens when the very last black dwarf disappears? Does information itself vanish with it? Or could it be that the universe has a hidden way of preserving everything that has ever existed? In physics, there is a deeply unsettling problem known as the information paradox. According to quantum mechanics, information cannot be destroyed. Everything that has ever happened, the formation of galaxies, the birth of stars, even the thoughts of every living being, should be encoded somewhere in the universe forever. But if the universe fades into total darkness and the last black dwarf evaporates, then where does that information go? Does it dissolve into nothing, violating one of the most fundamental rules of physics? Or could it be that black dwarfs themselves act as cosmic archives, storing the final traces of a dying universe in a way we have yet to understand? Some scientists believe that even after black dwarfs disappear, their information is not truly lost. Instead, it might become encoded into the very fabric of space itself. Imagine a universe where everything that ever existed is imprinted in an invisible structure woven into reality, something beyond what we can observe, something beyond time. Could this mean that the end of black dwarfs is not an erasure of the past but rather a transition to a new form of existence? And what if this information could be retrieved? If an advanced intelligence, whether natural or artificial, could find a way to access the knowledge stored in black dwarfs, they might gain the ability to reconstruct the entire history of the universe. Every event, every thought, every lost civilization could be restored. Could it be that black dwarfs are the keys to immortality, not just for life, but for the universe itself? But what if the fate of black dwarfs is even stranger than we imagine? What if, rather than fading away into nothing, they leave behind something unexpected, something we have yet to discover? Some theories suggest that when the last black dwarf decays, it could trigger a fundamental shift in the structure of the cosmos, potentially igniting a new era of physics we cannot yet comprehend. Could the death of black dwarfs actually create the conditions for a new universe to be born? If this is the case, then black dwarfs are not merely remnants of the past. They are the final seeds of the future. And if we could unlock their secrets before they vanish, we might uncover the ultimate mystery of existence, the answer to what happens after the end of everything. The final fate of black dwarfs may be the most mysterious and least understood aspect of the universe's future. They are the ultimate remnants of stellar evolution, the last dying embers of a cosmos that was once teeming with energy and activity. But what if they are more than just the final whisper of a fading universe? What if they hold the answers to questions that go beyond even the limits of physics? What if they are the last clues to something even bigger than the universe itself? When the last black dwarf evaporates, it won't just be the end of a single star, it will be the end of all observable structure in the universe. At that moment, the cosmos will have reached its final stage, absolute darkness. No more light, no more heat, no more movement. Every black hole will have evaporated. Every particle will have spread so far apart that interaction is virtually impossible. This is known as the heat death of the universe, a state of ultimate entropy where nothing more can happen. But here's the problem. If nothing more can happen, then how do we define time? Time, as we understand it, only has meaning when things change. We track time through motion, the movement of the planets, the flicker of a flame, the decay of atoms. But if black dwarfs are the last things to decay, then after them, there is nothing left to change. That means that, in a very real sense, time itself might stop existing. The universe wouldn't just be empty. It would be frozen in an eternal state of unchanging nothingness. But could time truly just end? Or is there something else waiting on the other side? Some physicists suggest that, in the deep future, something incredibly unexpected could happen. Just as particles randomly pop in and out of existence due to quantum fluctuations, what if the entire universe could spontaneously reboot? What if, after an unfathomable amount of time, a random quantum event ignites a new Big Bang? If this were true, then black dwarfs would be the last markers of one universe before the birth of another. Could it be that our universe is just one in an endless cycle, where each cosmic era gives rise to the next? And if that's the case, could black dwarfs be the final message left behind for whatever comes next? If an advanced intelligence ever arose, whether biological or artificial, they would face the same problem we do, the inevitable march toward cosmic extinction. But what if they found a way to preserve themselves by embedding information into the very structure of black dwarfs? If these objects survive longer than anything else in the universe, then they might be the perfect cosmic storage devices, carrying information across different eras of existence. Could this mean that black dwarfs are not just the remnants of dead stars, but message capsules for the next iteration of reality? Imagine a scenario where, trillions of years after the last black dwarf fades, a new universe begins. A new Big Bang erupts from nothing, a new set of physical laws emerge, and new civilizations form. What if, hidden deep in the quantum structure of space itself, these new beings discover traces of the universe that came before them? What if they uncover the last records of a universe long gone, the thoughts, discoveries, and experiences of a cosmos that once existed? And what if they realize that they, too, will one day face the same fate, destined to leave behind only their black dwarfs as clues for whoever comes next? If black dwarfs are the final objects in our universe, then their fate is not just a question of astrophysics. It is a question of existence itself. Do they mark the absolute end of everything? Or are they the doorway to something beyond our comprehension? Perhaps, in the last moments before the universe fades, before the last black dwarf disappears, there is one final, unknowable secret waiting to be revealed. One that could change everything we think we know about time, space, and the very nature of reality. If black dwarfs are truly the last celestial objects in the universe, then their disappearance marks a transition into something entirely unknown. But what does it mean for something to end? If black dwarfs are the last things to decay, and if their eventual demise marks the moment when all physical processes cease, then is this truly the end of reality itself? Or is it merely the end of the observable universe as we understand it? To answer this, we need to step back and look at a concept that challenges everything we know, the nature of nothingness. When we say that black dwarfs will one day decay and that the universe will reach a state of ultimate entropy, we are assuming that nothing follows. But is there truly such a thing as nothing? Even in the deepest voids of space, where no stars shine and no matter exists, we still find quantum fluctuations, random bursts of energy that pop in and out of existence due to the inherent uncertainty of the quantum world. Could it be that black dwarfs, in their final moments, trigger something far greater than mere nothingness? Some scientists propose that the death of the last black dwarf is not just the end of the universe, but the beginning of something else, something beyond what we can currently imagine. The very last decay, the last whisper of thermal radiation, could be the final spark that tips the universe into a new phase of existence. If time no longer has meaning after black dwarfs disappear, then what comes next might not even exist in a way we can comprehend. To understand this, let's think about how time itself could be fundamentally different from what we assume. Right now, we experience time as a continuous flow, always moving forward. But what if time is actually something that can be reset? What if, after a period of unimaginable stillness following the decay of the last black dwarf, the universe snaps into a new state, something totally unlike anything before? This could mean that black dwarfs are not just the last objects of this universe but also the catalysts for the next one. This idea brings us to a concept known as cosmic rebirth, sometimes called the Big Bounce theory. Unlike the traditional Big Bang model, which suggests the universe began from an absolute singularity, the Big Bounce theory suggests that our universe is just one in an endless cycle of expansions and contractions. Instead of fading into eternal emptiness after the last black dwarf disappears, the universe could undergo a quantum shift, collapsing into an ultra-compressed state before expanding again in a new Big Bang. If this is true, then black dwarfs might be the last remnants of the previous cycle, still holding traces of the universe that came before. But what if there's something even stranger at play? What if black dwarfs, rather than just decaying, transform into something we haven't even theorized yet? When black dwarfs decay through quantum tunneling, they emit bursts of incredibly low-energy radiation. Could these last emissions of energy leave imprints on space-time itself? If the universe eventually undergoes a new expansion, could these imprints act as the seeds for the structure of a future cosmos? It's possible that black dwarfs do more than just disappear. They might shape the physics of whatever comes next. And then there's an even wilder possibility. What if black dwarfs never truly vanish at all? What if, instead of decaying into nothing, they transition into an entirely new state of matter and energy? Right now, our understanding of particle physics is incomplete. We don't know the full structure of reality at its deepest levels. Some theories suggest that unknown particles, perhaps linked to dark matter or hidden dimensions, could interact with black dwarfs in ways we haven't even begun to understand. This means that instead of simply evaporating, black dwarfs might evolve into something else, something outside our current understanding of physics. Could black dwarfs be portals to another reality? Some physicists theorize that extreme conditions, such as those inside black holes or during the decay of ultra-dense objects, could potentially create connections between different universes. If black dwarfs concentrate matter and energy in just the right way before they decay, could they somehow tear through the fabric of space itself, opening a passage to a new realm? This is where speculation meets some of the deepest mysteries of theoretical physics. Right now, we don't know if parallel universes exist, but some theories, like those proposed by string theory and the multiverse hypothesis, suggest that our universe is just one bubble in a vast cosmic ocean. If this is true, then black dwarfs, rather than fading into oblivion, might actually be the gateways to other realities. And if they are? Then the last black dwarf would not be the end of the universe, but the beginning of something else entirely. But before we get too far ahead, let's take a moment to truly appreciate just how alien black dwarfs would be in their final form. Imagine a sphere of compressed matter, denser than anything in the universe at that point, sitting in the silent abyss. No light, no warmth, just an object that once shined as a brilliant star, now reduced to an unseen relic of a dead cosmos. Yet despite their total darkness, black dwarfs would still exert gravitational influence. Any last drifting particles, any last remnants of mass that somehow survived to this point, would still feel the tug of these invisible remnants of stellar history. But could anything actually detect a black dwarf? If they emit no light, no radiation, other than their near undetectable Hawking-like decay, and no meaningful signals, how would we even know they exist? In fact, the only way we might identify one is through its gravitational pull on nearby objects. If the universe were somehow still populated with wandering stellar remnants, perhaps neutron stars, hypothetical exotic objects, or even black holes, then black dwarfs could subtly reveal themselves by disturbing their orbits. This means that the final astronomers, should any conscious being still exist in the far distant future, would need to rely entirely on gravitational lensing and indirect measurements to find the last survivors of the universe's stellar past. Yet, even if we could detect black dwarfs, the real mystery is what happens at the very last moment. We've already discussed how these objects would eventually decay via quantum tunneling, But what does that actually look like? Unlike a dramatic supernova or a violent collapse, the end of a black dwarf would be silent, invisible, and almost unnoticeable. Over an unimaginable timescale, its fundamental particles, protons, neutrons, and electrons, would gradually find ways to escape, one by one. The process is so slow that if we could somehow speed up time and watch, it would resemble a mist slowly evaporating into nothingness, except that mist is composed of fundamental building blocks of reality itself. Yet, could there be unknown physics that changes the way this process plays out? One of the biggest mysteries in modern physics is whether protons are truly stable. Most of our current models predict that protons, despite being the foundation of all normal matter, should eventually decay over quadrillions of years. But we've never directly observed this happening. If protons are eternally stable, then black dwarfs might never fully decay. Instead, they could remain as cold, lifeless remnants forever, lingering in the void of an unchanging universe. But if protons do decay, then black dwarfs have an expiration date. Their structure will collapse, their remaining particles will fade away, and the universe will be left with only pure energy, drifting endlessly through the cosmos. No objects, no structure, just a vast ocean of ultra-low energy radiation, slowly stretching as the universe itself expands. This is known as the heat death of the universe, where all that remains is a uniform emptiness, colder than anything we could ever imagine. Yet here's the ultimate paradox. Could the absence of structure lead to something new? The very nature of quantum mechanics suggests that even in complete nothingness, random fluctuations can occur. These fluctuations, while normally insignificant, could, given enough time, lead to spontaneous events. Some physicists propose that, after an unimaginable eternity of darkness, a new universe could randomly pop into existence, birthed from the remnants of what came before. If that's true, then black dwarfs, in their final moments, might actually be setting the stage for the birth of an entirely new reality. This means that instead of being the end of everything, the last black dwarf might be the final necessary ingredient for the next Big Bang. If quantum mechanics allows for even the smallest chance that energy fluctuations can create new spacetime, then perhaps black dwarfs serve as the final domino, the last remnant of one universe, which through its own decay, contributes to the foundation of the next. But could there be an even weirder fate for black dwarfs? Some theories suggest that under extreme conditions, matter might undergo transitions we can't even imagine. What if, instead of merely decaying, black dwarfs transform into something completely different, something beyond our current understanding of physics? Right now, we classify matter into a few fundamental states: solid, liquid, gas, and plasma. But under the right conditions, new states of matter emerge: Bose-Einstein condensates, quark-gluon plasmas, strange matter. Could black dwarfs, compressed and aged over trillions upon trillions of years, give rise to an entirely new form of existence? And here's the biggest question of all: what if we're wrong about the fate of the universe? What if black dwarfs are not the last chapter, but merely a midpoint in a cycle far larger than we can perceive? Could it be that, instead of fading into nothingness, black dwarfs trigger something else? Something completely beyond our comprehension? If black dwarfs are truly the last remnants of a universe that once burned with billions of stars, then their fate might hold the key to understanding the fundamental nature of reality itself. But what if everything we think we know about their eventual decay is completely wrong? What if, instead of slowly disintegrating into radiation, black dwarfs undergo a transformation into something we can't even begin to comprehend? Let's take a step back and look at what makes up a black dwarf at its core. A white dwarf, the precursor to a black dwarf, is essentially a giant, burned-out ember of a once massive star. It's made of electron-degenerate matter, meaning that instead of collapsing under its own weight, the star is held up by the quantum forces of electrons resisting being squeezed together. Over time, as it cools, it will lose all of its remaining energy, becoming completely invisible and blending into the dark void of space. But what happens inside as this process unfolds? One of the biggest mysteries in astrophysics is what happens to matter under extreme, prolonged pressure. In neutron stars, which are even denser than white dwarfs, atoms get so compressed that electrons and protons merge to form neutrons. This results in a superdense object that can be just a few kilometers wide but contain more mass than the Sun. But what if black dwarfs, over quadrillions of years, undergo a similar transformation? Could their structure change into something even more exotic, something beyond neutron stars? Some physicists propose the possibility of quark stars, where matter is compressed beyond even the neutron state into a soup of elementary particles called quarks. But what if black dwarfs go even further, collapsing into something even stranger? There's a theoretical form of matter called strange matter, made up of a balanced combination of up, down, and strange quarks. Strange matter is predicted to be more stable than anything else, meaning that if a black dwarf ever reaches this state, it might never decay at all. It could remain as a cold, solid chunk of the most stable material in the universe, outlasting even the heat death of the cosmos itself. If this happens, then black dwarfs wouldn't be the last remnants of the universe. Instead, they would be the final survivors. While all other forms of matter slowly disintegrate into background radiation, these objects could remain completely intact, unchanging for eternity. They would become the only physical structures in existence, islands of hypercompressed, frozen matter in a universe otherwise devoid of structure. And if any form of intelligence were to survive this far into the future, black dwarfs might become the only remaining evidence that anything ever existed at all. But let's take this idea a step further. If black dwarfs collapse into strange matter, could they infect other forms of matter that they come into contact with? Some theories suggest that strange matter is so stable that, if it touches normal matter, it converts it into more strange matter. This raises an eerie possibility. If one black dwarf transforms into strange matter, could it start a chain reaction, slowly consuming any remaining white dwarfs or stellar remnants it encounters? If so, then the ultimate fate of the universe might not be heat death, but rather a slow takeover by strange matter, where all remaining objects transform into these cold, stable remnants. The cosmos wouldn't be empty. It would be dotted with eternal, indestructible objects, waiting in the darkness for something, anything, to restart the cycle of existence. But what if black dwarfs don't just sit there? What if, over unimaginable timescales, the very fabric of space itself undergoes a transformation? Some cosmologists propose that the vacuum of space might not be entirely stable. If a lower energy state of the vacuum exists, then, at some unpredictable moment, space itself could undergo a quantum phase transition. This could trigger a phenomenon known as vacuum decay, where the very structure of reality changes in an instant, wiping out everything in existence, including black dwarfs. This means that, even if black dwarfs outlast everything else, they might still meet a sudden and unexpected end, not through slow decay, but through a complete rewriting of the laws of physics. In this scenario, everything we know, including black dwarfs, would be erased in an instant, replaced by an entirely new version of reality with different physical constants, different forces, and possibly even different forms of matter and energy. But what if this isn't the end? What if black dwarfs, instead of being destroyed, somehow survive this transition? Could they act as the seeds of a new universe, carrying the last traces of the old cosmos into a brand new reality? Some theories suggest that, under the right conditions, highly compressed matter could trigger the formation of new spacetime itself. If this is true, then black dwarfs might not be just the last remnants of an old universe. They might be the building blocks of the next one. If black dwarfs hold the key to the birth of a new universe, then we must ask ourselves, what exactly would that process look like? Could the last remaining objects in existence somehow spark the beginning of something new? This idea leads us into the realm of cosmic rebirth, where the universe is not a single, finite event but rather part of an endless cycle. One of the most intriguing theories in modern cosmology is the idea of cosmic bounce models, where the universe does not simply end in heat death but instead collapses in on itself, only to be reborn in a new explosion, another Big Bang. But if this were to happen, what role would black dwarfs play? Would they be destroyed in the collapse, or would they somehow persist? Some physicists suggest that the compressed matter within black dwarfs could serve as nucleation points, tiny seeds of highly condensed energy that might survive the transition. If true, this means that the matter inside these black dwarfs could be the only material to carry over into the next universe, meaning that everything that comes next, galaxies, stars, planets, even life itself, could be built from the remnants of these ancient, dead stars. This raises an even deeper question: could something remain inside them? Black dwarfs are expected to be cold, inactive husks of matter, but what if, hidden deep inside their cores, some form of information storage exists? Quantum physics tells us that information is never truly lost, even when matter changes form. If the universe undergoes cycles of destruction and rebirth, could black dwarfs act as time capsules, carrying echoes of past universes into the next cycle? If so, then the concept of black dwarfs becomes far more than just the endpoint of stellar evolution. They could be the only structures capable of preserving something from the past, whether that's physical matter, the memory of a previous reality, or even the remnants of some long-forgotten intelligence that existed long before everything else faded away. But what if black dwarfs never even reach this stage? What if, instead of surviving to the end of time, they undergo a completely different transformation that prevents them from ever becoming the final remnants of the universe? One possibility that some physicists have considered is that black dwarfs could eventually become mini black holes. If proton decay occurs on a much shorter timescale than predicted, then as black dwarfs break down at the subatomic level, their cores could become unstable. The immense density of degenerate matter might cause them to collapse inward, triggering the formation of a singularity. If this happens, then black dwarfs wouldn't just fade into darkness. They would turn into black holes, disappearing into their own gravitational wells. This is where things take a mind-bending turn. If black dwarfs collapse into black holes, then these new singularities could start the process of Hawking radiation, slowly evaporating over unimaginable timescales. But what if, instead of simply vanishing, they instead lead to the creation of baby universes? Some models of quantum gravity suggest that black holes could serve as gateways to new regions of spacetime. If so, then black dwarfs, rather than being the final dead remnants of the cosmos, might instead be the key to the birth of countless new universes, each one branching off from the remnants of a dying reality. This means that the black dwarfs of our universe could, in some distant future, become the origins of entirely new realms, places where different laws of physics might govern existence, where time itself could flow differently, where the fundamental constants of reality might be completely rewritten. If this is true, then black dwarfs are not just dead stars. They are the architects of the multiverse, silent and unseen, shaping the fate of existence in ways we cannot yet comprehend. And if this is the case, then what does that say about our own origins? Could it be that our universe itself was born from the remnants of some ancient, long-dead cosmos, one where black dwarfs played the exact same role billions upon billions of years ago? If so, then everything we know, every galaxy, every planet, every star, might be built from the ashes of a universe that came before. And if that's true, then perhaps the cycle has been going on forever. If black dwarfs are not just the final remnants of stars but the very foundation of new universes, then we have to ask ourselves, is this cycle infinite? Could it be that the cosmos has no beginning and no end, but rather an eternal process of death and rebirth, where black dwarfs become the seeds of reality itself? This idea is linked to a theory known as eternal recurrence, where the universe is not a single event but part of an endless loop. If black dwarfs lead to new universes, then perhaps our own reality was once formed from the remnants of a previous cosmos, one that had gone cold and lifeless, leaving only these ancient stellar corpses behind. When they collapsed into singularities, perhaps they gave birth to new realms, places where physics reset, where time restarted, and where matter began its long journey toward forming galaxies and stars once again. If this is true, then black dwarfs hold a paradoxical role. They are both the oldest objects in existence and the very first structures of a new cosmos. They would mark the end of everything and the beginning of something new, linking past and future in a way that challenges our fundamental understanding of time. But here's where things get even stranger. If black dwarfs are responsible for spawning new universes, then that means each new universe could inherit certain traits from the one before it. This could explain why the fundamental constants of physics, things like the speed of light, the strength of gravity, and the masses of subatomic particles, appear to be so finely tuned for the existence of stars, planets, and even life. Perhaps these values are not arbitrary but are instead passed down through cosmic generations, shaped by the physics of dying black dwarfs. This could mean that the laws of physics are not truly random, but rather a product of natural selection on a cosmic scale. Universes that produce black dwarfs, and by extension, new universes, would continue the cycle, while those that failed to do so would eventually fade into nothingness, leaving no successors behind. This idea, sometimes called cosmological natural selection, suggests that universes may evolve in a way similar to life itself, favoring those that can continue their lineage. If this is the case, then our own universe may be just one link in an infinite chain, stretching backward into the distant past and forward into an unfathomable future. Each universe may give rise to the next, carrying with it the echoes of the one before. And if this is true, then perhaps, buried deep within the structure of reality itself, there are clues, subtle imprints left behind by the black dwarfs of a cosmos long gone. Could it be that the vastness of space holds hidden messages, fragments of information encoded within the cosmic microwave background, or the strange behaviors of quantum particles? If black dwarfs are the architects of new universes, then maybe, just maybe, we are living in a cosmos that carries the fingerprints of something even older, something that existed before time as we know it began. But if all of this is true, then what does that mean for the distant future? If our universe eventually cools into a dark void, leaving only black dwarfs behind, will these objects once again ignite the spark of creation? Will they collapse into new singularities, opening doorways to realms beyond our comprehension? Or is there yet another fate awaiting them, something that neither science nor philosophy has even begun to consider? And if black dwarfs are the key to the cycle of existence, then one question remains: where did the first black dwarf come from? If every universe is born from the death of a previous one, then was there ever a beginning? Or has this cycle been turning forever, with no first universe, no original spark, just an endless chain of realities, stretching infinitely in both directions? If that's the case, then black dwarfs are not just the remnants of dead stars. They are the most important structures in the cosmos, the silent architects of everything that has ever been and everything that will ever be. If black dwarfs truly represent the ultimate fate of stars and, by extension, the final remnants of our universe, then the idea of an endless cycle of rebirth raises an even deeper question. What happens to the information contained within them? The universe, as we understand it, follows strict rules about the conservation of information. This means that even if matter is transformed, the fundamental information about its past state should never truly be lost. But if black dwarfs eventually become the last remaining objects in existence, holding within them the remnants of every star, planet, and molecule that ever existed, then does that mean they hold the final record of everything? Imagine a time so far into the future that every last atom of ordinary matter has either decayed or fallen into a black hole. All that remains are these incredibly dense, frozen remnants of stars, scattered across a universe that is no longer expanding in any meaningful way. Because at this point, there would be nothing left to expand. If these black dwarfs do not collapse into singularities, but instead exist for unimaginable lengths of time, then they could serve as repositories of cosmic memory. But could this information ever be retrieved? Theoretically, the answer is no, unless some unknown process allows for the resurrection of past data. Some physicists speculate that in an infinitely long-lived universe, even the most improbable events will eventually happen. If so, then could there be some distant future where these long-dead stellar remnants reassemble into something resembling intelligence? Could black dwarfs, in their final moments, give rise to a form of self-awareness unlike anything we can comprehend? This may sound like pure speculation, but certain interpretations of quantum mechanics suggest that information is fundamentally tied to observation. If this is the case, then perhaps black dwarfs are not merely passive objects. They could be the very last things to experience the universe. Perhaps, as they near the end of their existence, some final process unfolds within them that allows for the information they hold to be expressed in a way we cannot yet predict. And if that is the case, then could black dwarfs be the source of the next great cosmic event? Could they, in their death throes, unleash an unimaginable force? One that doesn't just create new universes but somehow preserves the memory of the old? If so, then perhaps nothing is ever truly lost, and instead of an eternal cycle of destruction and rebirth, the universe may be undergoing an even greater process, evolution on a cosmic scale. If black dwarfs are more than just the final cooling embers of the cosmos, if they are, in some way, the key to what comes next, then everything we know about the fate of the universe may need to be reconsidered. Instead of seeing them as the remnants of an ending, we may need to start viewing them as the first step towards something entirely new, something beyond the reach of our current understanding. And if that's true, then maybe the universe isn't dying after all. Maybe it's just changing, and black dwarfs are the silent architects of what comes next. This video is for educational or entertainment purposes only, and information provided in the video may be incorrect. Like the video and subscribe to the channel for more such amazing videos.